All right, hello, let's get cracking. So, yes, gamedev DSL. We had this issue last time. This something in here causes something with actually just logging this causes a seg fault for some reason. And I've also tried just using a label like this. What if we just had message? Type U0 has no members. Okay. This is different though than what we got before. Okay, so I guess if type of has no members. Wait. U0? This is very strange. Is it saying that this is U0? I don't think we need the pointer here, actually. Why do we need the pointer? Oh, we need the pointer because of log. Yeah, that's true. And if we remove this, there's going to be some other issue, probably. Yeah. Well... Did I try this? Oh. Alright, I think we have to say comp time here. But this is super strange. U0 has no members. It's like it's saying that self is U0. Hello, Penguin. What's up? What's up? Type. Oh. What is happening here? Like for this to even compile this here, it needs to kind of hook up self with log write all, because we're calling it on this. And all of a sudden, now this is a type. Something is very strange here. Okay. Gotta type. So it's not from here. Do we ever get a type from here? No, we don't. So we get type somehow, but it's not from this part. And I guess the only other place is from log. What? Where is that coming from? Is that some? Is this some kind of inner workings of comp time that kind of goes through here, or what? What if we say this should only happen in comp time? Still same error, still same issue. So what if we shortcut? Okay, now it works. What the hell? I think that is some kind of weird, obscure comp time bug. I've never had to do this before, and it doesn't feel like this is supposed to happen. I don't know where that call is coming from. I'm not sure if there's a way to kind of get the call stack. What is this? Oh, logarithm. Okay. Huh. Breakpoint. I never knew this was here. That's pretty cool. Wait, these are deprecated, right? I thought these were removed. Oh well. What is this? CLZ. Is a kind of math thing? Most significant zeros. Okay. Variadic function stuff. In comp time, returns where the built-in function or whether the built-in was running in a comp time context. Okay. Offset off. Pop count. Counts the number of bits set in an integer. Population count. Okay. Prefetch. Tells the compiler to emit a prefetch instruction if supported by the target CPU. Yeah, this is for like optimization stuff. Pointer cast. Remainder division. Return address. What is this? Shift left, maybe. Shuffle. Oh. So does this, the trap, does that like, can you put, no, because how do you use it? You don't put anything in. I was thinking if you put a callback. Work group. I don't know what this is. Okay. I want to check out, I want to like source location. So we have module file, function name, line column. That's it. Stack trace. Oh, okay, wait. Oh, this takes a writer. Or it takes a well, a terminal is a wrapper around a writer. What if we do this? Write current stack trace. Standard debug. So if we encounter a type, I'm just curious. I'm gonna create a writer here. Except we don't have a writer interface for this. So I have to implement, I actually have to implement a writer interface here. Which you can do like this. So we have a comtime writer. You have, this is the thing that's we're writing to. We have a writer. The writer is, do you have anything? You have vtable, buffer, and the thing about this, I think we need to create you from outside, essentially. Or do we actually? No, I don't. Well, no. Yeah, vtable So basically, writer is vtable buffer. I'm gonna say is like empty, and we don't need to specify. Okay. All right. So then let's say now we need the vtable. Vtable is writer vtable, and do you need to be a pointer, by the way? Yes. Right. So here we have a bunch of things we need to implement. I don't rebase. I don't think we, because there's like a default rebase, default flush, drain, send file. So I don't think we need send file. We're gonna need drain. I think that's the only thing we're gonna need. So we'll get drain. We'll have a function drain. And drain is supposed to be this type here. Returns a usize. All right. So how do we implement drain? Sends bytes to the logical sink. Right. So this is simply the job of this function is just to send, bytes to wherever it needs to be written to. So if it's a network call, you send bytes through the socket, for example, or if it's a file, it sends bytes, like writes bytes into the file and so on. I think this is essentially being called whenever you want to flush out the buffer, essentially. And if there's no space in the buffer, drain is automatically going to be called. So yeah, I write here will only be sent here if it could not fit into the buffer or during a flush operation. So buffer is consumed first, followed by each slice of data in order. Elements of data may alias each other but may not alias buffer. This function modifies writer end and writer buffer in an implementation defined manner. Data length must be non-zero. Right, so since we know that we don't have a buffer, we don't need to worry about writer end or writer buffer, because they will always be 0 and empty. So I think that essentially the last element of data is repeated as necessary, is written to splat number of times, which may be 0. This function may not be called if the data to be written, could have been stored in buffer instead, including when the amount of data to written is 0 and buffer capacity is 0. Number of bytes consumed by data is returned, excluding bytes from buffer. Number of bytes may be 0, which does not indicate stream end. A subsequent call may return non-zero or signal end of stream via write failed. Okay. So that is the implementation details of drain. So essentially, we're gonna loop through. So first you do the buffer, but the buffer is always gonna be 0 in this case, so I don't really care about that. And then what we do is we loop through data. We need to keep track of how many bytes we've written. So we start at 0. We loop through all the data, and this is gonna be the next message here. Now what to do with this message? Well, we simply add it to written here. So that's gonna be this. Oh yeah, and also self is going to be equal to field parent pointer. Field name is writer, and field pointer is W. So this is a way to kind of it's like getting the interface implementation. and this is that, so we know which type it is. Oops. So now we can get written here, and we can modify it, and we also need to increase bytes written by message.length, and in the end we return bytes written. But also the last element needs to be of data needs to be written n number of times, which is splat, which can maybe 0. So actually we need to not take the last element. So we'll remove one element from the end, and then in the end here we'll go through splat number of times, and we will write well, this is message here, yeah. And then the message here will be data length -1. So the last element of data is written splat number of times. Okay, and that's it essentially. So now we've implemented the writer interface here. I'm gonna remove these functions because now we don't need these anymore. Okay. There we go. And now this writer function does no longer have like write all and stuff like that. So what we will do is, this is the comp time writer, and then the actual writer itself is going to be comp time writer.writer. Whoops. And then you say ampersand to get the actual writer. Now this is the writer. It has, now we have the full actually like writer interface with all different kinds of functions, which is real nice. And we can just write all if we want here again. All right. Is there like a write repeat or splat? Write splat. Right, we can actually do a write splat. Yeah. So instead of doing this, we could do like write splat space depth number of times. Okay. We're also using it here. You can also just say labels writer like this if you want. All right, so this is the comp time writer. We'll have a writer. Okay, so what do we want to write out here? We want to write out... actually, you know what? I'm just going to do this to make sure this still works here. Oh, error. Right. So, comp time value, self. Okay, this is actually an issue because I don't think we can put comp time here. That's gonna be like a type difference. Yeah. Can we just write view in comp time? Can you actually not... Do you not work in comp time? Maybe because W is not comp time in this sense. I see. Okay, so it's a little bit more complicated than I thought. I mean, I guess one way would be to copy this interface and change all the W writer to comp time. I wish it would check this. Hang on. Unable result comp time value. Now this one is called... So we just need to kind of make sure this is a comp time var, I think. Okay, well, we do get a different error now. You can't do this though, because now that doesn't work. Also, it's redundant apparently. Yeah, okay, maybe it's like all calls to those functions has to be in comp time context as well. What if we just wrap? I mean, this doesn't work because we're already in comp time. Yeah, and now we get some other issue. Okay, maybe this didn't work as I thought. Why did I want to do this? I'm not sure actually. I don't remember now. We could just go back to the old implementation that we had because that actually did work. I'm not sure why. Oh yeah, I wanted the interface because I wanted it to work with the terminal. That's right. So write stack trace. I mean, what we could do is we could just go to the source code here. I guess as long as we don't pass writer in. Ah, this uses an arena stuff as well. We don't need that though. Stack iterator. I was thinking like copying this, changing this out to a writer, like our writer, as long as we implement all of this, like all the functions that we call, it just calls print, which we do implement. Okay, where are we now? What if we say comp time here though? Yeah, it doesn't work. Okay. I'm thinking maybe we could do this another way, another way. I don't really know how though, because it kind of considers this to kind of a runtime. And there's no way to get some other type of context here. Maybe unless we use like a global comp time. That's not constant, is it? But I think, yeah, they removed this. You can't do this anymore. I think you used to be able to do this, but then now you can't. Yeah, you shouldn't be able to do it here either. No. I was thinking, like, because we know it's comp time, so there might be some way to kind of make it think it's comp time, but I don't know if it works. Like, if we put comp time here, I don't think it will accept that. It will just say that it's not a comp time expression. So maybe field parent pointer, you can't actually get that in comp time. This has to be, this is comp time. So if we if we get the offset and we get the pointer to writer, which we have there, and we do some pointer arithmetic, so we've got that minus the offset, right? And then pointer from int. And now this is comp time. No. Good morning, Packrap. Guten Morgen. God morgon. How are you this morning? It's due to this operand. Oh, I see. Now it actually explains. Maybe it did that before as well. Is it the same reason here? Did I just not look at this? Wait, forces comp time evaluation. Okay, now it doesn't actually explain, right? It doesn't explain what the issue is. If we go over here, it explains that the W is the issue, which it is, but again, it's not as well. At the same time, it's not, because it is from a comp time. It's like everything is in a comp time context here. God damn it. Oh, you're still awake? Trying for 10 hours to set up virtualization server. Holy crap, okay. Sorry to hear that. You must be tired. Well, at least we know now that the YouTube chat is working again, so that's good. And the thing is, we can't just dump it either, because it's in comp time, so you can't write, you know, and it's using an allocator. You can't use allocators in comp time either, so that's gonna crash. So actually, even if, okay, that just actually slipped my mind. Even if we do get to call this with a terminal, it still uses an arena, so it's still, this will still cause it to fail, because we're in comp time and arenas doesn't work in comp time. Like they crash the comp time, or yeah, there's gonna be like a compile error. So it doesn't work. What do you use the arena for? Oh my god, why? Get symbols. Needs an allocator. Okay. Okay, whatever. My curiosity is is has been deleted from this earth. Let's go back. We can't implement this in comp time as far as I can do right now, so sure. Let's not do that. Oops. Format. Yeah, void. No, this is right. All. And print will write all. Comp time print. Because there's no comp time writer, as far as I can tell. There's an allocating, but that of course does not work with comp time. All right. All right, so we're back here. And I mean, I guess I could technically kind of go in, basically copy everything from their like stack trace functionality to be able to write out where this is coming from, maybe, if there even is a stack trace here. I just don't know where this is coming from. So what's happening here is like I encountered okay. First of all, I'm working in Zig in comp time. So everything here is happening in comp time, essentially, except for a few bits at the end. But all of this is happening in comp time, even though I have a comp time thing here is just to make sure that the computer, it like understands that this is happening in comp time. So there's no like ambiguity there. But yeah, so everything is happening in comp time. So there's a different kind of rules applied when you're working in comp time. And so I encountered an error while calling this function in comp time. And for some reason, you know, this parameter here is a comp time self pointer to this. And this is just a type here, parse context, a struct. Okay. Now, in order to call this function, you have to pass in self, which has to be a parse context, right? And you have to I even say like self dot or like context dot log write all, and the compiler hooks all that up, right? But sometimes now I've encountered it actually doesn't pass in a parse context into here. It passes in a type, which I've discovered, and then I actually have this kind of comp time short circuit here to make sure that we don't continue here, because we got all kinds of bugs down here because of that. So if I discover that self is no longer this type, it's instead some kind of type, like I don't really know what it is. Actually, what we could do is we could actually write what it is actually. If I log out the type name of type, or just the type itself, we can see what it is. Oh yeah, right. So this is the writer now. And we don't have... Okay. Right. Wait, what's happening? Okay, hang on. First of all, that's what's going on there. What's this? Function call at runtime cannot return value at comp time. Reference by here. Oh, did I miss a spot? Wait. Wait, I didn't encounter this before. Okay, let's remove that. Let's remove this. And I'll add comp time there. Okay, there we go. So we got a compile log. Alright, yeah, I should have known this because it did say that before. So this is the thing. Like sometimes when we call this function with self, it says that self is not a pointer to a thing. It says that self is a type, like self is a type and not an instance of a struct or a pointer to a struct. It's a type, and the type it's u0. So so what I did to solve this issue, I just say, okay, well, let's not actually call, like, let's not do anything if it's a type, and then all of a sudden it works. So now the program runs and I get all these log messages. And I think it's because of this one here. If we didn't call, like, let's say, I have this log back, because when you have a compile log, when you trigger a compile log, the compiler sees that as a failure, so it will error out. So when I want to test this, if we don't call log out here, if it will work, and now it will work. So for some reason, this this, when we call this here, is considered a u0 type, which it makes no sense whatsoever. Like if we compile log type of context here, we get a bunch of parse context. This is from label. So there's something weird going on with like the mapping, because this one comes from the inner compile log. It's like after we call log write all, it checks the type of self and it says it's a type, it's u0. But when we log what context is out here, it says something else. So I see this as like a compiler bug or something. It's super strange. So I have no idea why it's happening, but I mean, this is kind of like a workaround, I guess. There might be other implications here that I have no idea about. Like there could be other issues that this is causing, or that comp time is simply unstable to use in this way. Like it works for the most part, as from what I've tried things. But I'm using comp time extremely a lot in this project, and I'm starting to get these kind of weird issues. So yeah. Comp time u0. Okay. I don't know. There's a lot of stuff that they have to work with. But yeah, interesting. Sorry, Packlap, I haven't read your messages in a while here. It's fine, it'll take a while. It's an old Dell server retrofitted with a 12 disk RAID SAS 15K drives and some SSD. Only nerve-wracking thing is the fans, which are turbofan props. I never messed with that kind of stuff, like RAID stuff, and basically having a stiff neck and tinnitus for 4 hours. Oh man. Did you try to run versus another version? Yeah, I'm gonna just give that up. Totally was seeking the error on the defer, potentially causing a lazy and valid runtime. Yeah, I'm kind of programming kind of like a kind of weird context. I wanted to find an issue that talks about binding type parameters. I couldn't find that. There's like a proposal that here we go. Yeah, this is from Andrew as well. Urgent. This one is yes. Remove any type. Sounds good. And type of, which I was curious about. Why remove type of? Because I feel like that has like a utility that cannot be covered by. I mean, I guess, okay, if you look at this here, zoom in a little bit. So the thing that what this is essentially removing type of, which you would use all the time, essentially, for looking at what a type is. And that, I guess, is going to require a lot of refactoring in the standard library. And basically every code base out there. But it's good. It's for the better. So I like it. And they should do these kind of they're breaking changes now when the language is unstable. So there's no issue with that. Any type also is very much used in projects. It's a really nice thing to be able to have because it essentially allows you to do things you can't do with just comp-time T type things. Because you could still inspect what type you get, but it's kind of like you can get anything, and then you can inspect what you get, and then do different things depending on what type you get. But now they want this syntax here, which is kind of like capturing. This is the capture syntax, and then you get a type out, which is really, really cool, because then potentially, I'm not sure if they're gonna allow pattern matching, like you can have, but I guess we'll see. So type of single-handedly responsible for language specification complexity. For example, langref contains this text expression or value, however they are guaranteed to have no runtime side effects. It's not too bad, but it's certainly a special case. There is no other built-in syntax that behaves this way. I mean, sure, that's fine. This proposes to remove the built-in entirely, along with introducing syntax that addresses the use cases of type of. Yes, very cool, very cool. Additional motivation here is that any type is awkward because it only looks, because it looks like a type, but it's actually a syntax. Yeah, you can't use it as a type. You can use it sometimes in places where there is a type that's supposed to be there, like in function parameters, function parameter types. You can use any type, but you can't use it as a type itself. You can't like you can't declare a variable to be the type anytype, because it's not a type. It's like a special thing that kind of, yeah, does things. It's actually syntax. Renaming it to any val does not address the fundamental. Yeah, it's just a rename, so it doesn't do anything. However, unless there was other things happening in here. But however, unless type of is removed, then an additional way to get inferred type is no good. To get the inferred type is no good. Right. Better to always rely on type of than to have two ways to do it. Variable declaration example. All right, so we have type of our declaration. So result equals foo. So result will be inferred to be in I32, right? And so we assert that the type of result is I32. So this is how it works now. And then it would work like this. So to get the type, you don't use type of, you use a binding, you use a capture. You capture the type by, I guess, having it in like a type context, like this. So you specify what is the type of result. Well, we don't know, we capture it. And then we check what type it is. So I like this change. Because yeah, it does remove type of, which is kind of awkward sometimes to use. I like this the syntax better here. Yeah, and it may perhaps allow as well for in-place capturing, but we'll see if that is what they want to do. Like, I was thinking like pattern matching, like the syntax allows for it at least, where you can have pattern matching on types, which could lead to constraints. I'm not sure if they're gonna have it, but it could be like, let's say, because you can't do it in comp time anyway, because you can still look at T and say that, oh, if this is a you know, a array, for example, of something, then you can still like extract the type out from the array, child type, and all that. So you can still like inspect the type to kind of have constraints built in. Well, not built in, but built into the function that you call. However, it would be nice if you could pattern match like in the types. Like, let's say you put like an array here. So now it's like an array and you capture the child of the array. I'm not sure if they're gonna do that, but that would be really cool. Function parameter, because then you could do some other cool things. Well, you can kind of do that now anyway, but now we have to use like any type. This at least makes it a little bit more, you actually capture it directly. So you save yourself a bit of typing as well. Okay, so this one is simply expecting foo12 to be 12. So foo_x is any type, and it returns type of x. So this is how you have to do it now. And then this is how you do it later. So that's good. That's an upgrade there. So the difference, yeah, you don't, so the difference is like less characters, which is really nice. You don't have to type any type anymore. You just capture, and you don't have to type of. This is really awkward, this everywhere. It also looks a bit bloated as well. So I really like this change here. If they do it, I don't know if it's like been decided that they actually do this. Okay, downside of this would be losing access to peer type resolution as a built-in. For example, this function from standard math would need to be rewritten. Keep in mind, peer type resolution works on values, not types, because comp time known values influence the result. Peer type resolution works on values, not types, because comp time known values influence the result. So like we have 3 different types here, potentially. And then, yeah, and then this is the peer type resolution, right? Because type of, yeah, okay. It can also be used as a tier type resolution. Okay. So it will, so what this will do is if you put multiple things in here, it's gonna like try to, it's gonna do this kind of collapsing of the types or something like that. It's gonna like peer type resolution. There's an algorithm for that. Like it looks at all the types. If they're all the same, it's just gonna be that type. If they can be, yeah, I don't know. There's some kind of algorithm to do that. And this would be the result here. We would have to have a function that actually implementing peer type resolution in userland. So there are actually, I was actually surprised at this. There are some things that is not like, I thought that the whole zig compiler would be part of the standard library, but that was not the case. It just has some things regarding the zig compiler in the standard library. So the zig compiler actually lives somewhere else, like the code for the zig compiler. And I think it's also, I'm not sure if it's even fully zig. Okay, well, most things are zig, maybe, I guess. Here we have LLVM. Well, some things are C++, I guess. Actually, you can look at... Do you have like what GitHub has is like percentages of different languages? No, you don't. At least not here that I can see. Well, anyway. So, yeah, so then I would have to implement peer type resolution in like Zig, the Zig standard library essentially. I mean, they have the implementation. They just need to move it here. I'm not sure how it's implemented, but this would be a really nice thing. I think, from what I can see here, it's essentially, what do you actually gain from this? I mean, it kind of like, from this thing here, you just gain like a little bit of syntax niceness, essentially, which is good, you know, but then you actually lose some things as well. But then I wish they would do like pattern matching as well, so you could actually pattern match on generics as well. I don't think they will do that, because that kind of goes against, I guess, like the philosophy of Zig or something. Sorry. Okay. Anyway, let's see if we can fix this issue here, and I will switch to RPG. So, the issue we're dealing with in the actual implementation here. So what we're doing here is we have like a language. Let's see. And here is what we have so far, essentially. Now, how this works is that I'm basically parsing this. So a lot of things is happening in comp time. If we go to main, ignore these sources. I can remove this. So essentially, the compilation is happening in comp time. Everything here is in comp time. So we get a compilation out, compilation result. The result has a bunch of stuff that you can inspect the tokens, the AST, and we also get an IR, which is like what we would use and then actually run the thing. So it's kind of like an interpreter sort of here, but it's like a compiled interpreter, you could say. Okay, and then we get the compilation context, which is needed for I think like type information, stuff like that. I think, I don't remember now exactly because it was some time ago when I did. Okay, and then if we get a compilation result, then print out a bunch of tokens and stuff. We will then run the actual program by evaluating the IR with a new IR context, and this is happening in runtime. So this is the thing that happens in runtime. But everything else before that is happening in comp time. So what that kind of means is, essentially I'm using Zig compiler as, I'm kind of extending the Zig compiler to be able to compile my new language as well. And then we get a compilation result out, and then this is run now in runtime. So when we run this, when we compile this, it's actually compiling the game code sort of as well, or the language, this language as well. It's compiling this as we compile with Zig. It compiles this as well, and then gets passed here in runtime to actually, if we then run the program, we run it here. So it's kind of like, well, either you can call it embedding another language maybe into Zig. I don't know. You can call it whatever you want. So the new capture T basically becomes a neutral object to hold any type. Yeah, it's just a binding. It's just like a type. At least it's just a comp time identifier bound to a type, which depends on what you input into the, basically depending on the, it's gonna be the inferred type. By the way, why is standard math lowercase? I thought Zig uses Pascal case for those. So it uses, okay, so types are usually Pascal case, while modules are lowercase. So these aren't seen. I mean, that technically is the same thing, because this is just actually a struct here. This is actually just a struct, because it's a file. It's like a module. Well, I guess technically it's different in like Zig, but they both are a struct. All like modules are structs in Zig. So if you import like a file, std.zig, now you have it's like a module, but it's also a struct. So it follows all the rules of structs. You can define, these are a bunch of declarations on the struct. You can even have fields. So you can have a field here, like, you know, that, because if you, and then you can instantiate the struct std if you want. You can actually do that, I think. You know, this is this. But the thing is, it doesn't actually have any fields or anything, so there's no reason to do this. But it's kind of like, it works out, because it kind of like structs can be seen as both modules or namespaces or structs as well. And some files actually, they implement them as actual structs as well, like allocator, for example. A lot of places actually in the standard library implements different kinds of things as structs directly in the top level. But yeah, if you see like this and in a lowercase, it's because it's kind of seen as a module or a namespace instead of a actual type. So that's how that is. Capture T, wait, no, Capture T will basically move the type check to the function signature instead of being nested. Yeah, it's an inferred type. So it's inferred based on what you pass into the function. So, where is it? Yeah, so here, T will be determined when you pass in something here. When you call foo. So at this point, it's gonna infer basically like comp time int or whatever this type will evaluate to. It's gonna infer that as T, and then that's gonna be the return type as well. So you can kind of see this as like in C++ you have templates. I'm not sure if templates can be inferred though. I don't remember, or maybe they added that. I don't know actually, but because, or if you always have to pass in the actual type into the template like arguments. But this is kind of like implicit, like saying that T is equal to whatever type you put in here. So yeah, that's how that is. It would actually, it would also change. No. Okay, so yeah, I think essentially this is just making it a little more terse. I think that's all this is gonna do here, unless they would implement pattern matching, because that would be kind of cool. But it just feels like this syntax. It just feels like this syntax change that doesn't actually give a lot of things. It's just a nice to have, I would call it. Anyway, and it's gonna cost a lot of work because in both like the standard library and in projects, because I think everyone is using typeof, everyone is using anytype, so this will be a big change. But I think it's for the better. But I wish they would do it. I wish they did it sooner. But yeah, anyway, well, this is what you have to live with when you work with Zig. You have to live with these changes that come around that changes the whole thing. So I don't mind it. Like that's what you have to know that beforehand when you make a Zig project. You have to, yeah. So you can't complain because you know it's gonna happen. And you can like mentally prepare yourself by looking at the news or something. Okay, so std.it is basically the register of the module hierarchy. Yeah. Well, yeah. I mean, okay. So you import standard. Now standard is kind of like normally when you import something, you import a file like this. This is relative to the current file. And this is exactly the same thing. It's just that std stands for like an alias that was that is points to the standard library. So this is like a super special thing. Also, that is only used, you know, in programs here. So, and then there's another one. So there's two, I think. There's standard, and then there is built-in, which has some other stuff. And then there's root as well. But root always points to the entry file of the compilation thing. So there's three special things, and then the rest you import as only files. So if you go in here, all of these submodules, like if we go to the submodules here, are just import commands. So it's all like not recursive, but it's all like, well, using this import construct, essentially. Was introduced in 2020, I think. We're talking about like inferring... Wait. Regarding C++ equivalent would be concepts, which is templates with constraints upfront into signature pattern. What? Concepts? Wait, what the hell is that? I've never heard of this. Concept hashable. Oh my god. Every time I get so curious every time I hear like a new language construct. Excuse me about the flashbang here. Maybe I can enable like dark reader or something. I usually have it off because it messes with the styling. Declaration of concept hashable, which is satisfied by any type T, such as the values A. For values A of type T, the expression standard hash A compiles and results convertible to standard. What? Is this like comp-time constraint computation? Or what's happening here? Such that for values A, typenet T requires TA. Okay, so T is the type, A is the like the value kind of that we're looking at. Values for values A of type T, the expression standard hash T A. What does this mean? I'm just gonna pretend it's just like we're hashing it. Compiles, and its result is convertible to standard size T. This seems so specific. What? Okay. It's convertible. Wow, this is a super strange syntax here. I mean, I guess I'm not used to it. Also, we have a struct meow here. For some reason. Is that is that even used? Concept. So is this a runtime constraint or what is? No, it's a comp time because it just says that this should compile, and then this is like convertible. I'm just so confused about this syntax because it leaves you wondering. Okay, how do I use this? How do I actually do things with this? Constraint C++20. So is this how it looks? I guess it's new because it says concept here. Template hashable T. Okay, so now this is a constraint. So we need something that is hashable. Alternative ways to apply the same constraint. Template T requires hashable T. Oh my god, why do they do this? I feel like that's a problem with C++. It's like there's too many things to do the same thing. And then they like, yeah, you can do it like this as well. I guess, I mean, it could have its uses maybe. But yeah, that was just funny to me. Template type name T requires hash table T. So I guess it's good because you can have like hashable T. Maybe here you can add more requirements after. I guess. Okay. And I guess the same thing here. Maybe you can choose where to put this anywhere you want. Basically, consider pulling all your comp time notions inside a function into the signatures you have the check up front. Okay. Yeah, I mean, that's good, I guess. Although in Zig, you can actually take with comp time. Okay, I'll show you here. So let's say we have a function. Let's say you have an enum that is like, I don't know, animal. I'm just gonna make up a scenario here, cat and dog. Okay, and then we have a function that get animal sound or whatever gives us a string. Here's an animal. Now notice that this is not a comp time animal, it's a runtime animal. Now this doesn't really show off the same thing, but I will show you why it's good to have comp time in inside a function as well. Because now we can switch on animal. Cat gives us meow, and dog gives us bark. Okay, let's return this. Okay, now the problem is that this, well, it's not really a huge problem in this case, but you know, this is all runtime, so it's like you pass in an animal, it has to check what it is. Yeah, we don't gain anything from this though. That's the thing. But what if you wanted to kind of return a different... Okay, I'm gonna change this scenario a little bit. What if you wanted, because I realized that you don't actually gain anything from what I was gonna do. But let's say you wanna return... Actually, let me show you what I was going to do. So instead of doing this, you can do like inline else. And then you get the T. Now the T is now a comp time known tag, so you can use it generically with comp time. So let's say now you have a function that takes a comp time animal. Let's call this comp time. Okay, and now when you do switch on animal, it's in comp time, which means that the final like code that gets compiled will be one of these cases and not a switch and then the case. It's gonna like compile into one of these cases. So essentially, let's say we have this code here. If you call this function, you would get this out. Like the compiler will evaluate this in comp time, and the result will be a string, which is then put in the result wherever you want to use it. So, which means that this is never going to be run at runtime. So, and then you can use that here. So you can like return. I guess we don't return there. We return here instead. So now you can return get animal sound CT T, which is the comp time equivalent here. So you return that, and well, for this contrived example, it's like this doesn't actually gain anything from this, because we essentially still in a runtime context, we're still getting an animal, we're still switching on it, and the branches will still, you know, exist and all that, and then you still get a like, so this is kind of equivalent actually to what we had before. So these two functions now are kind of equivalent to this function without comp time essentially. but it will allow you to kind of map a runtime value to a comp time context, which is really powerful sometimes, because sometimes you might want to, let's say you want to return a different type. Let's say you have like a, I don't know, get, let's make another one, which is like get animal type or something, or payload or whatever. So then you would do like, this gives us a type now. And we get an animal in, but notice it's not comp time, but we can make it comp time by switching on it, because it has a exhaustible, well, it doesn't have to be exhaustible. You can also do it with integers, actually. You can do this with integers as well, as long as you cover all the cases. So, so then it's like, well, we're making into a runtime. We can also, or a comp time, I mean. So this would give us, well, let's say we have a cat, is a struct, and a dog. So we have these two types, and here is like, well, now we're kind of in comp time mode, so we can switch on. It kind of looks weird here, but dog will give us a dog, and cat will give us a cat. Okay, so this should work here. So now you can pass in a runtime animal, and you get a different type out depending on what you have, I think. Anyway, wait, can you actually do that? No, I don't think you can. Never mind. No. You can't get another type based on runtime. No, you can't. No, you can't get another type, but you can't. So the type cannot be different. But what you could do is have like a similar, like if you have a type that is, I mean, let's say like this. Man, I was gonna demonstrate what you could do with this. Well, anyway, there's probably other examples. I can't actually think about that runtime. I need to actually have a good example and not like bring it out of my ass. So yeah. Never mind. But you can't turn a runtime into comp time by doing that. But then you can't. It's like you can't like, yeah, you can't like return a different type based on a runtime. Then you have to have a comp time known type. But this is possible. This is possible. So it's like you can turn a runtime into a comp time, and then call a function with the comp time known, and then do some generic stuff with that comp time stuff. So that you can do. You just can't like return a different like type here depending on the runtime, because the compiler has to know what type you bring back. What you could do though is you could do like any opaque. Yeah, but anyway, let's forget about this. I need to have a good example next time ready. Okay, but anyway, we're soon gonna switch over to the RPG here. I just wanted to fix this issue here that we have for a while now. So let's do this now. So basically, what's happening is that I have this language, and the only thing I have right now is that I have expressions. I have, well, the whole program is like a list of expressions separated by semicolons. And then we have bindings, which is always const right now, and identifier equals, and then some other expression here, and then semicolon. So, and then we can also, and then this is another expression, which is an identifier expression, which is just an identifier, and then we have number expression as well. And that's all we have right now. And the issue is that whenever I put negative in there, we get an error. If I put 5 in here, we also get an error. Interesting. Okay, I think let's fix this first because I think this is a different. This is actually a compiler error. So parser2 470. Oh, this is in bind. Interesting. Expected type string found node. Called from where? Parser, so parser run 334 gdev 64 Discord bind. Oh yeah, I was actually experimenting with Discord bind here. So parameter type. So what are we doing here? We're making identifier. This is a node. We return a parser node. That is correct. Here we're returning a parser error. Well, it is a node. And then you turn it. Yeah, you have a parser and a message. Parser parameter type declared here. Oh, wait. And then you're saying that A is actually a node? Yes. Oh yeah, because this is a node. Right, I need S. Oh my god, okay. See? Okay, that's a major downside of this system, is like debugging is not as straightforward when using this type of stuff. Unless, especially if, like, unless I can get better debugging messages, like, especially if, you know, we're not reading this log here. This log pointed me in the correct direction. So as long as I have this log, I can kind of find the issue. But yeah, with comp time stuff, things are like erroring not at where the issue actually is. It's like erroring somewhere else, it feels like. Okay, now we got another issue. Parser2 346 expected 2 arguments. Oh yeah, you expect a label. So this is pure or error. And what do we get now? Error union with payload. Error union with payload type. Oh, so you can't have an error union with an error union payload. Interesting. I didn't know that value had an error union actually. Which means that pure, someone's calling pure with an error somehow, somewhere. Somehow. This is a node. Yes, it's a node. So where is this called from? parse, discard, bind. Oh, it's called here. Which parse... Right, so we have parse error. So we pass in error. You can't have error as a payload. Right. Oh, actually, oh yeah, you can. Well, okay. Here I want to then maybe investigate the type of value and... Right, so the payload type is going to be like, if value is a parse error, then the payload is actually void. Otherwise, or actually payload is T. Because it should be the same thing. Yeah. Yeah, it's just T actually. You know what? It's just T. That's what it is. But then value can be parse error or T. So there we go. $471. Expected type, node, no type found, error. Right. Result is try, bind, parser, run, context. And then we do init. Wait. No, this should be... Wait. This is the parser, right? We get a result out. We should just return this. I don't understand why I put dot init there. I'm not sure what happened there. Okay, there we go. And now we get a working... so, okay, back to this. This works now. And the final result is 5, which is because in like a list of expressions, or this is called a sequence technically, the result of the entire expression sequence is the last expression. So anything else is like above is like discarded in the final result. So this will be so because I put my variable here, it's just gonna print out my variable in the end here, because that's how I have it set up now. And here we can see the tokens and also the entire AST, which is just a binding, and then we have an identifier. So there we go. However, the problem is, as soon as I put -5 here and run, we're gonna get some compiler errors for some reason. Now the thing is, I went to specifically cover this case with the number literals. So we're picking if we have a minus tag. If we have a minus tag, we also consume that tag, that token. So the minus is 1 token. So when we get here and we consume it, or peek on it and see that it's a minus, we also consume it. So we go over to the number, and then we consume the number here. We expect it to be a number, and then we parse the number essentially down here. So that's what we do when we parse a number literal. And the only difference here is just that we put a negative here. So I don't really understand why there's an issue, but that's what we're trying to figure out. So, and here's like parse expression is either binding, discard, identifier, number literal. So we're going to test binding first, which is, this is a binding, so it should work in the binding. Now the binding is like a sequence of const, keyword, an identifier, a equal token, and then some kind of expression here, which should then go back and test binding again, which will fail because it's not a const keyword. It will fail discard because it's not an identifier. It will fail identifier because it's not, and then it will go into number literal. But we don't really know what's happening, so I implemented a log, which kind of shows like every path that's being taken here. So we're logging out all the different things happening here. So here's the main parser, is this one. And this one calls parse expressions, which we don't have labeled actually. No, we do have it labeled, but it's not being actually put out here. So maybe, let's see. Well, we know that this is kind of the parse expression here, but we can also make it specifically labeled as well. So we can say label so that we make sure that we know that this is parse expression. There. So now if we run it, we're gonna see that in the tree. Yeah, so parse expression, which is one of parse binding, parse discard, parse identifier, parse blah blah blah. I have a bad format here, but whatever. Binding, identifier, identifier as expression. So then we get expression again. So this all works here. We're parsing these things. Now what I would say for token actually, I'm going to, because it would be nice to see that it's parsing the token maybe, I don't know. Now this is not labeled. We could potentially label it with the tag actually. The problem is, you know what, let's put like options in here as well for the parser options, because I want to be able to set like are you do we want to like have this in the debug log, for example, or not? Actually, let's just put this as a struct here. Hello, no H for game. Do you use LSP? Yes, I do. Okay, so this would have like show, like hide in debug or something. Log, hide in log, or show in log, or hide in log. Show in log is a bool. I would set it to false as default. So now nothing should be shown in the log. This should only happen. Should we also just not do this? Yeah, let's just not actually log this. And now we have like a bunch of places we need to add an option everywhere. Yeah, so there is an LSP, but it's like sometimes, like especially with comp time stuff, it doesn't help you all the way. But it does have a lot of stuff working. But sometimes it just gives up. Zila's supposed to show you errors while you're coding, so why does it only show you when you compile? Well, it does show. It does do that, but I've disabled in my editor. I've disabled that it. Yeah, I've disabled it, so it doesn't show while I code, because I feel like I just think it's distracting. So it's just for my focus. And so when I press the button, so if I do this and I press the button, or okay, there's something wrong now, so let me restart. And yeah, so either I can press my command to see all the errors currently, or I can do this. Oh, let's do this. And then if I press my like go to next diagnostic button, I can see the error, but I don't see it like at all times. All right. And now, for example, we get this error. Very good. And here's like show. And this is a case where I don't actually get help, because I would like to, but I don't for some reason. So it also doesn't actually recognize that this is a thing for some reason. Show in log. Yeah, see, it doesn't autocomplete this one. But once I put it in and I look at the type, it knows what it is. And I can even go to reference. But it doesn't help me with the autocomplete. Sometimes it does, and sometimes it doesn't. So, but yeah, I'm glad the times I get help. Otherwise, I have to kind of do it myself. All right. Yeah, we have other places as well. If we explicitly put a label, I guess we want to actually show the thing, because there's no reason to put a label otherwise. So this would be show in log is true. Expression, yeah, same thing here. Okay, you see, now I get it for some reason. This time I got it. Sometimes it's because of syntax issues. Like if you have a syntax error at some point, it doesn't help you at all, essentially. But as long as you fixed your syntax, now it all of a sudden it knows everything. Hello, code guy. What's up? What's up? What have you been up to? Map, find, parse number literal. So what we could do here is we could actually skip this now because of this, and we can call this just parse number literal and show in log is true. Is that it? No. Handle error. Try parse. All right. Oh my god. Semester exams. Okay. Hope it's going good. Do you feel confident? I think this might be an issue with Neovim because I don't have these kinds of problems when I use Z. Interesting. Are you saying that your LSP works perfectly? I'm not sure if it has to do with... Like, the thing is, it works sometimes and sometimes it doesn't. So it's like a very specific circumstances. Some like auto completion does not work. Okay. Cool. So we got parse expression, binding. So now we have like all these nicely put here. Identifier, identifier. Do you wanna do like the tokens? I might wanna log out whenever we take a snapshot and whenever we restore a snapshot. Actually. And also maybe the snapshot can have an ID so we can know which one it is. Okay, let's do that. Let's do like snapshot ID. And whenever we create a snapshot, we need an ID. And then we add, well, whatever, it doesn't matter that much. We can just increase this. Okay. And then whenever we restore the snapshot, we are going to, so when we take a snapshot, we are going to log snapshot took our snapshot created. And then whenever and this has indentation built in, yeah. And then whenever we restore, we are going to say snapshot restored, and now we have ID there. It does its job pretty well. Okay. I mean, yeah, most of the time it works pretty well, I would say. It's just that some things it sometimes doesn't work. The major thing that I wish worked better is like when you have like a more complex comp time thing that produces a type based on like logic. So I've shown this a couple of times, but essentially, let's say you have a type T that depends on some comp time logic. So you have like you have an if comp time true, then you have an F32, let's say, otherwise you have U32. It doesn't, the compiler does not understand, or I mean the compiler understands, but the LSP does not understand what this is, even though it's like clearly going to be F32 because it's even like in comp time here. So as it works for like generics when it comes to like just if it's a function that takes a comp time T type and returns a type it knows what t is, and it knows all the functions that you use for, like, let's say an array list of t. It knows that all the items in the array list is of type t and stuff like that. It does know that. But as soon as you have these kind of logic, like control flow stuff in ComTime, it doesn't understand what it is. So I wish this would work with LSP. Maybe they're working on getting this to work. I don't know if it's going to be too much work to make that happen. I don't know, but yeah, that would be kind of cool. How's the game going on? It's going good. It's going good. I'm just working on the language a little bit in parallel as well. So I'm trying to get this. I'm trying to get this thing sorted out, and then we'll switch. Okay. So here we can see all the snapshots being created. Essentially, this would happen when we have a try parse. So this is like the one-off, I think. We create a snapshot. So we have the binding test here. If it's an identifier, this is the discard test, I think. No, it's not. This is just parse identifier. Yeah. I think we can skip parse identifier S, maybe. Parse identifier S, we don't really need to show that, I don't think. Yeah, we don't need you. So I'm gonna just remove this label. All right, so parse binding, parse identifier, and parse expression. In my other language, I also have, like, it shows kind of like a tiny bit of the code as well, like the code line, and it shows like which is the current token and what's the next token, how many tokens have we peaked into and stuff like that, which is really handy as well. Yo, Sunil, what's your take on React and Java Spring Boot versus Mern? I don't know how to pronounce that, but yeah, I know what it is. Man, which one is better to learn to make money later and more opportunities? I don't know. It depends on, as I've always said, Cold Guy, as I said, like every time we talk about this, it depends on where you're looking for jobs. So, because that determines what jobs are available. So if you're like only let's say you're looking for jobs in your area or in some other area or something, just look at what jobs are available. What do they search for? Are there many Java jobs? Maybe you should learn Java then. Are there many like React, Mern, Stacks things? Then go learn that. So that's the answer to that question. But I will say, like React, like globally, React is very popular. Like as a front-end library, it has basically taken over everything essentially. So you basically can't really go wrong with React, I would say. Java is another thing because it's like the backends are more diverse. The backends are like you can have like Java, there's C#, .NET, Node, like there's all kinds of different backend stuff, like Go, for example. And I think that, well, learning React, I think also what's important there is like you can't also go wrong with HTML, CSS, and JavaScript because that is what it's all based on. So if you learn that, then you will have less problems with React as well. But React has another dimension to it where it's like you have composable things and you have state being thrown around and update. So it's different, but then it's all built upon HTML, CSS, and JavaScript. So you can't go wrong in deep like exploring those things more as well. Oh, you hate React though, H4Game? I mean, why do you hate React? I feel like React is fine. I mean, sure, like I wish I could just do things in native HTML and JavaScript, but the thing is, you always come to a point where you kind of, oh man, I wish I could compose this, or I wish I could have like, well, you kind of can compose, I guess, with web components. I've never really went down that route seriously, but it's like, when I make a web component, it always feels very clunky and slow compared to React. And then there's things like you can use like JSX compile maybe to web components or something like that. I don't know. Don't you dare say React is fine. What's all this hate about React, man? I think it's a good framework. I mean, I think maybe people are just tired of it because that's all there is now, essentially. Why don't you go with Angular? Or, I mean, you could go with Vue, or like there's a bunch of different things. Okay, so what is happening here? We're creating a snapshot, parse binding, parse identifier, parse expression. This one should now. Okay, yeah, it fails all these things, and now we're creating a thing here, but it unexpected token expected number literal at. So why does it expect a number literal? I am very confused. Is it something wrong with the consume function, maybe? Because we're checking here, like, is the next thing a minus? In that case, consume it, and is negated is -1, which kind of is like a weird, I guess, sign. We could have it, it's probably a better name, sign. So if we pick a minus, sign is -1. If sign was -1, that means we need to consume it as well. So if this all works, I would say that this should work. Or if this is all. Okay, and then let's go in here. What do? You take the tokenizer. Wait, what the hell? Why are we copying it? Oh my god. I think what's happened is that, okay, the issue here is we're copying the tokenizer and then advancing the copy. So the original never actually changes. I think what happened was I copied this function over to make consume, and then I just left tokenizer in here, not like realizing that it was a bug in the making. Okay. Oh, now we get this error here for some reason. That was strange. Why didn't that show up before? Okay, oh well. And now it works. Finally. Okay, cool. So this little thing is now working. And if I, for example, if I put 1 here, it's gonna compile the whole thing. It's gonna compile this code, and then it's gonna spit out 1. If we run it again, we basically have an IR now that it's evaluating in runtime. So the runtime code essentially now is like has this IR that it's running it. Is this runic or what? No, it's not runic. This is a new language that I'm like dabbling with here. Okay, what do you have against React? React is absolute hell, and a major reason why nobody actually understands what happens. That just sounds like skill issues to me. But yeah, I mean, you have to learn how the what the framework does, like what the framework is doing that you're using before you actually do stuff. Like, I don't see why people have so much problems with React. Like, I can understand that you want to be able to reason about the code in an easy way, but then again, coding is not like it's meant to be easy. I guess sometimes it's like sometimes it is hard to solve some problems, and it depends on kind of what approach you have to the problem. But yeah, just saying that it's bad is not really. I don't think so. It's like, yeah, some problems are hard to solve, but it doesn't mean that the framework is bad. It just means it's a hard problem, I would say. Like, and some frameworks work better for some things, while other approaches works better for other things. So it's like you always gain and lose something. Like if you go back to native, as I said before, like, yeah, you can get up to speed quickly and you can like do things very quickly at first, but then you realize, hey, I also lose things like components, like composability and sharing stuff, and stuff like that. No, it does a lot of necessary stuff in the background, which leads to unnecessary resource usage. I guess Svelte is better when it comes to resource consumption. I mean, yeah, sure, I guess. Svelte is good too. Svelte is really nice. I discovered Svelte kind of early on, and I was like, this is amazing. But then it had it didn't have TypeScript support, and it had kind of, but now it looks pretty good. Before someone uses React, they should be forced to write the equivalent with bare Ajax when we talk. Then we talk. It depends on the. I think React is it's good if you have a larger project. That's the point. You treat it as a framework, but it does no magic. It simply is a forced way to stockpile modules. I do not say React is hard. React is just bloated nonsense. But it does give you features that you wouldn't have with native. Essentially, it makes it easier. Like if you learn React and you do things the React way, you can be faster than like more productive than you would be working in native. And yes, it is bloated. It's like there's a lot of things going on, but sometimes you don't need that optimization. Like most of the time, I don't think most like websites do not need that kind of optimization to just make everything native, and then React is like good enough. And if you value productive speed like more than optimize it, like performance, then that's good. Is gdev linked maybe? Did I have this on? Okay, I'll do that. Fixed stuff. It is on. Here. That should work. If you want to write anything related to JS, learn JS. Yeah, you should definitely learn JavaScript, because that's the whole basis of the whole thing. Like, yeah, you should do that. Like that, you have to do that anyway. Like React is like a thing that is on top of JS. And a lot of stuff is like you have to use the API that is the JavaScript API or the browser API anyway. And that is all, the browser code that, but it also, it's available in React as well. Hello, Blue. What's up? What's up? How to beat skill issues? Just practice. Get better. You get better with time with just practice. Everyone starts out somewhere. There's no shame in being at your level. It just means that you haven't, started earlier, I guess. Imposter syndrome. Yeah, I actually have that all the time. Every time I go get into a new company, I feel like I have imposter syndrome. But then I realize that I don't know. Sometimes it depends. It's like some people have when you meet new people like in the workspace, you realize that there's a lot of different skill sets, and some people are good at some things, some other people are good at other things. You are good at your things, and that's just the way it is. We shouldn't feel the imposter syndrome as long as you're in there. Do your best, and it should work out. Only thing that helps is just doing stuff you need to walk toward confidence, constant repetition, slight change. Yeah, just practice and do the thing. All right. So there we go. Now we're ready. Like I'm ready to expand on this language, but we're not gonna do that now. I'm gonna do that next time, because now it's time to go over to RPG. Cool. Great. And we push this, yes. So let's go over here. And now we're in this project. Okay. Now the thing is, like, I'm contemplating whether to... Oh, yeah. Actually, before I say that, last time we were working on getting a new type of enemy in here, which is a goblin archer that has a ranged attack. And you have to be close enough. And there we go. There's it trying to attack, but something goes wrong. And essentially, the goblin is like disappears. So I don't know what's happening there. So let's figure that out. Goblin, no, it's monsters. So I mean, I guess it's something to do with the ranged attack. The deranged attack. We have a projectile with the target, which is the player. The projectile itself just is created there. The ranged attack itself is doing stuff. We are doing the action. So let's go to ranged attack here. And so we have the target. Is that correct? Yeah, we pass in the target here. That's the target we put into the ranged attack. Yes. And then this kind of calculates target position and the starting position, number of steps to take, and the speed at which we move. And then that's gonna be that. And what we see is essentially we see the kind of the ranged attack being spawned. The goblin disappears for some reason. Okay. Right. So first the attack, or first the projectile is spawned. We move the projectile, and we move towards the move step. But that doesn't seem to happen. There doesn't seem to be any movement going on, which is weird. Let's double check something here. Player, is this correct now? Player character. That should be correct. Yeah. Okay. We could log out maybe when we create the ranged attack. We could log out like all the things. So basically, ranged attack. Projectile position. Target position. Steps. Move step. Alright, so prototype position, target position, steps, move step. Let's log that out and we'll see. Okay, let's go over to this guy. So right, here we create the ranged attack. Projectile position, right, so it's different there, yeah, so that makes sense. Yeah, it starts to the right, correct. Target is to the left. We have 36 steps, and we move 36 pixels each step. What is 36 times 36? 9. Wow, that's a lot. That's not correct. Okay, so the move step is wrong. That's one thing that's wrong. Then I don't really know why the goblin disappears. But yeah, we can start there. The move step is bad. It's wrong. So move step. So essentially, yeah, I'm trying to calculate basically how many frames, like, or how many, like, yeah, how many frames do we want to display this animation for, and how many pixels do we move each frame, essentially, sort of. So, so we calculate the relative position between the target and the projectile, which means that it's going to be from the goblin towards, no, wait, no, from the projectile towards the player. Yes. And that's going to be negative because this is larger, well, in this case. So that's good. So there we have the relative distance, which should be like what was said there, like 36.0 in this case. Then we have the distance, which should just be 36. We have the number of steps, which we take distance over speed. And the speed is something. It's just 1, I think. Yeah. Speed is 1, which says that the number of it's 1 pixel. So 1 pixel per frame, which means that now we have like 60 or 36. 1 second, I'm getting a call here. All right. 1 second here. Okay. I just need to make a move here on a thing. Quickly. All right. There we go. Cool. All right. So, are you guaranteed to have steady frames, or can they drop? They can drop, but it doesn't matter. It's just like if it starts to lag, like everything slows down essentially. So yeah, I don't think it will though, because this game is not gonna be super demanding if we put it that way. I think the most demanding thing would probably be the pathfinding. I mean, I guess if we have like a lot of pathfinding calculations, it depends on how many entities we're gonna have and all that, and how big the maps are and stuff like that. But then again, we can also always reduce the amount of pathfinding. We can like reduce the area that things are pathfinding in, so it doesn't like try to pathfind the whole world, you know. But it so we could do something like that. Or let's say most of the time things are probably not pathfinding anyway, because they probably only pathfind if you do something to aggro the enemy. Otherwise, they will just move around randomly, essentially. But yeah, we'll see. But this essentially what this is just how many physics frames, how many physics steps are we gonna take towards the target, and this is how far we're gonna move. So I think it said that the move step was like the same as the number of steps, which is wrong. So, which I can see now, because we're taking the relative distance and just dividing it by 1. So it's just gonna be 1 step, so that doesn't make sense. I think we need to take like steps here, actually. Yeah, this is gonna be divided by steps. You know what? Why don't we just do this, and then we don't... There we go. Now we don't have to worry about that. We can put in anything here, essentially, as long as it converts to a F32. There we go. Problem solved. Okay. So now move steps should be good now, I think. Oh. I see what happened. Okay, so I see why the goblin disappeared, because it removed the goblin and the projectiles lay around here. Okay. Interesting. We're moving the goblin and not the projectile. Great. So, okay, yeah, this is wrong. We should move the projectile and not the goblin. The problem is, where is the projectile? The projectile is actually on, I think. Let's get the projectile body. Projectile body. I don't know what happened there. And we'll move you instead. Projectile body. Oh yeah. Right. The goblin never moved. The goblin shouldn't move at all. So we don't need to do anything there. Okay. Oh, and now we get an error. Let's see what happened there again. Oh man, I wish they wouldn't spawn that close. Okay, well, it looks better now. But we get a crash instead. There is some kind of maybe thing that doesn't exist anymore. Something that we need to check, like if it's valid or not. Range attack 15. The body of the oh yeah. So we only need this over here. Yeah. There we go. Because the projectile gets destroyed, and then yeah. I don't see a damage number though. But it does work here. Oh, wait, why is this guy not attacking? It is attacking. Okay, cool. And now we die, I think. And then there's an issue because I don't handle that case. Okay, cool. Shooting goblins instead of bullets. Yeah. Like, yeah. I mean, you can launch a goblin, I guess, maybe. You have these games where a giant troll takes a goblin and just throws it over. Okay. I've also been thinking about the system here, because the generic action system is essentially, there's two parts to it. There's the actual like board effects of the action, because it's turn-based, right? So it's essentially like a board game. So you have the board effects, which happens at the onCreate function here. This is essentially the board effects, which happens immediately. So that will just, whenever the action is decided on and taken, this effect will happen. So this is the board effect happening here. And then the other thing, which is like the major kind of thing here, most of the code it relates to, is the animation of the board effect. So there's those two parts. And what I was thinking is like the animations can get messy, perhaps sometimes. Perhaps you have, well, actually sometimes the board effect has to calculate maybe something that has to do with animation as well. Let's say you have a bouncing bolt, a magical bouncing bolt that bounces off walls. You have to kind of calculate a list of bounces, or because everything needs to be pre-calculated. Yeah. And then that information can be stored, and then when we show the animation, we just replay essentially what happened. So that's kind of how it works. But what I was thinking is maybe, because the way I've been implementing these animations is very specific to each thing, but we could probably, I'm seeing like a pattern going forward. So maybe I can make a more generic like system for showing animations, which could be like, you know, tweening bodies here and there. And then when that is done, you have like maybe you have like a chain of animations that happens in sequence. Once one thing is done, next thing happens there, and so on. So maybe something like that could be a thing that could more, so you can more easily define and change and reason about the animations instead of having to manually do everything all the time. So I'm seeing like the pattern growing here. But anyway, before we have that, we have to do it manually, and then I will refactor it at some point. So yeah, we kind of have like ranged attacks now. I mean, yeah, that's great. I want to check like the AI here, because it felt like it didn't attack all the time when it could have. Maybe it... Well, the aggro distance is... I guess... Whoops. Where is my game? There. The aggro distance is like 3 over like this. So if you're standing here, we won't aggro the goblin. But if I move up there, it's going to aggro. If I move down there, I'm kind of out of range of the shot. So if I move in like this, I'm not sure if this counts. It goes in a circle. I'm not sure if we're like inside the circle. I think it counts the center. So if I go up here, it won't attack because I'm out of range. So that makes sense. But if I go up here, I get attacked. If I go there, I do get attacked. Okay. Cool. But I don't see the damage number. So let's fix that. Yeah, why? Oh, wait. Because we go to draw, and there should be like damage somewhere. Draw attack damage. This only works for melee attacks right now. I guess we could loop through melee attacks and range attacks and do the same thing. And I guess we'll have an interface, sort of, here. However, this doesn't work because we need to... Okay. I mean, I guess we'll try get melee attack first. If that doesn't work, we'll get the range attack, because it has to be one of those. So there we go. Now this is like either melee or ranged attack. Oh, incompatible types, right. God damn it. That doesn't work. Well, you know what? Then we'll do like another function. And we'll do like draw attack damage at offset. And we get like position. We get offset. Now what is offset? Is that a U size or what? Yes. Okay. So then we do this. Oh, and we need the actual damage as well. All right. Okay. I mean, I guess but can you actually decouple animation still as well? Well, it's just gonna be like, yeah, I can, because it's like I'm working with ECS, which makes that actually pretty simple to, or simple, I shouldn't say simple, but it is very possible to have like a decouple, like animation, like I don't know, animation effect system or something, I don't know, animation chain system or something that will kind of orchestrate different animation chains. So I can demonstrate that, actually. Maybe we'll do a little taste of that right now, actually. But I want to do this first here, so we'll try get a melee attack, and otherwise we have a ranged attack. And then we have the damage offset. It's gotta be melee attack. Like if melee attack, we get damage offset. Else, we get ranged attack damage number offset. And if we have a damage offset, then we call draw attack damage at offset attack. Oh man, we need like damage and stuff as well. Okay, maybe it was better the way it was before. We just actually god damn it. So we can't do this. You know what? I'll just copy. You know what? This would be a good maybe not a good time, but it would be a nice thing that we could do to actually have something that the melee attack and the range attack are actions, so they have like an action interface. But we could also do like an attack interface as well. So you would get an attack, which would be an action in itself. It's kind of like a chain of inheritance, sort of. Not really inheritance, more like a chain of interfaces. An attack is an action. A ranged attack is an attack, which it also is an action as well. So that could be something, because then we could just get the attack and we could do the same thing, because all attacks should have the same kind of stuff going on. Maybe. I don't know. Maybe not, actually. Because some attacks might have multiple targets and stuff like that. But anyway, okay, whatever. Actually, you know what? The damage numbers should probably be its own. We should, yeah, okay. Let's do this instead. Let's do it the easiest way. We create a component. Now, this should be part of the animation system. Oh, maybe we'll do that now. So basically, how I'm thinking about that. Okay, first of all, I just want to make this work. First of all, so what I was planning to do was just this. There we go. And now we have two different versions of the same function. We call draw melee attack damage, and this one is ranged attack damage, and then this one will be ranged. All right. So that's it. Now we should see those. Display position, we don't have. Right. I guess end position is kind of display position. Yeah. Sounds more like a ticket system and ledger to me, actually. Basically a task, schedule, event-based. Yeah. I mean, yeah. It's going to be, essentially, it's still going to be like a system that gets called every frame and just updates things based on what animation is going on, or any number of animations, actually. Okay, there we go. Now we can see the kind of damage number as well. Okay, cool. But what I wanted to do was the animation. But before that, I was thinking of another thing. Usually in roguelikes, because this is kind of like a crucial pivot point. Because I was debating whether to make this a mobile game, like touch friendly, or just make it a full-on like classic roguelike where you just have a bunch of keyboard keyboard keys to work with. I don't know. This is the thing, because if we would make it keyboard based essentially, then instead of using like WASD to move around, you would use the numpad keys, because then you can move diagonally as well. I don't think I have to decide that right now though. I think I would rather keep it open. It doesn't affect that much right now, the things we're doing right now. So yeah. Well, another thing that it does allow you to do is press 5 to wait for an enemy to move towards you as well. Which you can kind of see here. I'm trying to demonstrate how this goblin is supposed to like move. There we go. Now I can attack, because otherwise I get 2 damage. Yeah. Okay, anyway. So that's one thing. Another thing is... Yeah. No, the thing that we wanted to do was implement kind of like an animation chain system. I'm not sure if I want to call it animation chain, because it could potentially be a tree as well. Animation tree. And a tree and the nodes can be chains or other trees. Well, essentially a chain is just a chain of branches and a potentially into a tree. So animation tree, perhaps. Animation tree system. Well, as I've said before, like multiple times, PackRap, the highlighting is just for debugging purposes. It's not supposed to have highlighting. I'll remove it, because it's just for debugging. So draw hitboxes. Why? Oh, right. The hitboxes is like something else, right? No, not hitboxes. We should have like enable draw board state, which is happening somewhere here. So it's like if enable draw board state, then we draw the board state. So now that's turned off. There's not going to be any highlighting. So this is how the game is supposed to look. You just move around without any boxes around things. And yeah, there we go. Which is like, the boxes is like, yeah, it kind of maybe changed the feeling a little bit. I don't know. But it also wasn't really what I had intended to start with. All right. Anyway, so that's more like how it was supposed to look. Binary tree, though, would you like to kick off cascades of animations, initialize this? So it doesn't have to be binary, because the idea of a tree is more like, well, you have a starting point, the root, of course, but yeah. So how I'm thinking, like, okay, actually, let's diagram this first, maybe. Let's do some diagram. I usually never do this, but it feels like this is a good application for this. Whoops. No, it's better if it's... What happened? I think I removed the background layer accidentally. I didn't know you could do that. Okay, so basically, so we have like animation, I do have a drawing pad, but I don't think it works right now. Animation tray. Excuse my really bad mouse hand drawing here. So basically we have the root node. Okay. Now the root node can be like, it can just be skipped over or something essentially. But the idea is that each node in the tree would have children. So any number of children. So it would have like, this could have another node down here, and then we have like any number of children, and then there's like a children out here. You know. So it can have any number of children. It's not a binary tree. Because the point is not to search through it, it's just to execute everything in it. Now for every node in, so basically how it would work, does it even need to be a tree? I don't know. But essentially what it would be is that one animation can kick off other like one node could kick off other animations. That's essentially how I wanted to kind of, maybe this is more conceptually how it would be. So basically you start at, so this is the start of the animation here. And then you can kick off any number of sub animations. Okay. And then you can kind of schedule. So let's say you have, actually, maybe it's not a tree. Maybe it's more complex, actually. Okay, let me put an example here, maybe. So, for example, just a melee attack, I think, can be. So this is the melee attack animation here. We have a starting point. We spawn an animation that will move. So this animation here, the animation node is like move monster, or move like attacker towards target at a certain speed and a number of steps and all that stuff, right? So move the attacker towards the target. When this is done, we have like another animation that's gonna get played, which is like move attacker back, right? Move attacker back. So that means it's like first you move into the target and then you move back, right? That's kind of how it is right now. However, at the same time as we kind of went into the enemy and starts to move back, I want the damage number to show, right? So that means that when this is done, we want another animation as well being spawned over here, which is going to be, so this is move, well, we can't, this is move the thing, this is that, and then we spawn this animation, which is show damage. Okay. Right. So in this very simple example, you already have two animations being played kind of at the same time. We have a chain of events. We start out here. We start to move the attacker towards the target. When that is done, two animations are spawned, which are separate. But what I was thinking as well is that what if you want to wait for both of these animations to play and then do something else? Then it's no longer kind of like a tree. It's more, it's something else, because you want to wait for both of these and then do something, right? So these has to be kind of connected somehow. So it's not really like a tree. It's more like, I don't know. It's something else. It's like, you know, it's a system. Generic system. Chain of events. It's like a scheduling system, right? So, you know, we schedule to wait for these two. When these two are done, it's like a promise, you know, or async, you know, async await sort of thing. We're waiting for these two to be done, then we do something else. Right? I get what you say for the tree. Wait. Regarding the highlighting, I know it's debug only, but I will try to keep it into tutorials introductions. Yeah, maybe. Yeah. That's actually a really good idea, actually, because it kind of shows to understand maybe what's happening under the hood or like in the board state. So that's actually a good idea. Thanks. I get what you say for the tree, but always differentiate between what is turn ignited and what is a follow-up of another animation that can be independently spawned on the turn. Wait, let me read that again. I get what you say for the tree, but always differentiate between what is turn ignited and what is follow-up of another animation that can be independently spawned of the turn. Well, the thing about the animations is like the board state has already happened. So it's like it's not gonna, the animations will never affect the board state. The animations is only there to display what already kind of happened in the board state. So it's like you have things like it looks like it moving around. It looks like someone's like shooting you and then something happens, but really in the board state that thing already kind of happened essentially. So the animations is basically just a replay of what happened in the board, because otherwise we would have to show every animation separately. Each entity would have to show its animation before the next entity could do their turn, and then we'd have to complete that animation before the next one to do their turn. So in the case where you see all these goblins, every time you move, you have to watch every individual goblin move, do their turn, like in sequence, instead of they can move at the same time. But it's not like they're moving at the same time, like in the kind of board game rules, because they are taking their turns, and when the previous entity has moved, the next entity will take that new position into account when it like decides what it should do. So, but when we display what happens with the animations, then we can like play more animations at the same time. It's kind of like, I don't know if you've played Final Fantasy VI or any Final Fantasy that has like any kind of, you know, turn-based RPG where they kind of do the same thing there. It's like sometimes, even though usually like in older or like JRPGs, every animation is played out and then the next animation is played out and then the next animation is played out. Sometimes they show multiple animations happening at the same time. And that's kind of the thing that I want to happen here, like multiple attacks happening, like visually being shown at the same time, even though they are technically in order. Because it's like pre-calculated what should happen, and then we just display what actually happened. You inhale Final Fantasy 6 and 7, by the way. What does that mean? Did you spit it out? Was it a good hit? No, but yeah. Yeah, I had Final Fantasy 6. We had it on a European Super Nintendo, but the cartridge was American, and so it was called Final Fantasy 3. And so, but we had like an adapter. You could play through an adapter. And Final Fantasy 7 we had for PlayStation. I don't think Final Fantasy 7 had displayed things happening at the same time, I don't think. Final Fantasy 6, no, I don't think Final Fantasy 6 did that either. I don't remember now, but I think the later ones might have done it. Or there are other RPGs or other JRPGs that did it that way. Anyway, so this is the kind of structure that I want. It's more like a thing where you spawn up these. You spawn up like kind of like a blueprint of the animation structure, and then it gets put into a scheduler that plays this animation first. Then it like decides, okay, when this is done, then it should play these two. When those two are done, but when both are done, then go ahead and play the next one, and so on. And that could spawn any other number of animations, and then maybe we'll wait for these two to play another animation. You know, it can be as complex as we want. But this is the kind of structure that I'm looking for. So let's see if we can make that in a simple way first here. So I'm not sure what this would be called. I guess animation schedule or blueprint. A schedule would be kind of on point, perhaps. Or blueprint, or sequence. I played it on all platforms, initially on PSX. It hit, yeah. It was great. I also very much like Final Fantasy 9 is probably my favorite out of the PlayStation ones. Even though I've never played Final Fantasy 8, but I've played 7 and 9. I've played, and then I haven't actually played anything else above that. Like 10 and up, I haven't played. But I played, like, you know, all the ones up to 9, except for the third installment. I haven't played yet. So yeah. Yeah, I've played a lot of Final Fantasy. Final Fantasy Tactics as well. Final Fantasy Tactics Advanced 2. There's a lot of good games. Anyway, animation sequence maybe. That's pretty good name. Let's start with. We can always rename it. Okay, animation sequence. So yeah, as I said, this. Okay, so we need kind of. I think what we need is the animations to kind of be. Okay. There's another thing though. What if an animation is like conflicting with another animation? That is, they are going to affect kind of the same entity, essentially. I'm not sure about that. We'll figure it out, but I think we could make this happen. So what I'm thinking is that when you wanna do the range attack animation, for example, we could spawn a new entity that has the animation sequence, and then that animation sequence gets played out, and when it's done, we would consider the attack done, essentially. I guess the attack would have to... Maybe the attack is then... It's like it's connected to an animation, and then when the animation is done, it's gonna also cause the action to be considered to be done, essentially. I think, yeah. All right. Yeah. This would be good. I'm gonna BRB for 1 second here. I'm gonna refill my coffee. So be right back. All right. You stopped at FF15. I think X+1 was the last I played. Okay. Sometimes I go back and just replay the old ones. Like Final Fantasy 4 and 5. I think Final Fantasy 5 I've played probably... No, actually, I think Final Fantasy 1 I've played the most times. But then maybe after that I've played 5 a lot of times. 5 is it's pretty cool because it's you have such a lot of variation. So there's like a lot of like replayability. I think 1 also has replayability because you can like choose your team, you know. And 5 has like a bunch of different like jobs that you can choose and stuff like that. Really cool system. Okay, so what do we want to have here? I'm contemplating different things. So I'm contemplating whether to, let's say each of these could potentially each of these could be an entity actually, with a specific animation in place. So then we can scale up however we want for that. The question is, how do we govern this in that case? How is this defined? It could just be another entity kind of having this animation, but then it's waiting for this. So that could be a separate component. Like this could be one component. Like I need to wait for this. Like when this ends, I'm gonna start my animation. And then that animation plays. And then I guess the type of animation can just be, so basically you can have one animation. So then essentially we won't have an animation sequence component. We would have like an animation, well, I guess it could still be called a sequence, but it would just have one animation on it. And then kind of rules for... Actually, it would have to... How would we know how to create like what would the next be? Because it's either... We could either have it be like... what I'm thinking, like having it... My first thought was have it in data somehow. But another way to do it is just through function calls. And that could kind of be just a state machine, actually. Like a state machine where first you start here. This is the initial animation being played, so that's the first state. Then we go into a second state, although... Yeah, we play 2 animations, I guess. And then when both those are done, we go in the third state. What then when we have like parallel things going on? Let's say... Yeah, that doesn't really work. It only works in this specific example because all of this is kind of sequential. But what if we spawn out different branches that goes haywire? Then it makes more sense to have one entity per node. Because then it can be scalable or scaled up. You wanted to create a directed acyclic graph that spawns visual cascades. Yes. if it's cyclic, it will never be completed. Unless there's like logic at some point that waits for something else. It has to have input from something else then. But that will probably not happen. I don't know, maybe... No? Because the animation can... These nodes can affect any entity in the game. So they would be able to like move anything. They would move like, you know, the player or a monster or anything. Even if it's spawned from a monster. Like even if like, yeah, it can basically do anything essentially. And moving a projectile, for example, or even spawning the projectile probably would happen as well in this system. Like spawning, like just an effect to be displayed, and then move that effect over. I'm just thinking about how the architecture here would be. It was not as simple as I first thought. I don't think it can just be simply a state machine because of the limitations that I just talked about with parallel updates. I mean, technically we could have parallel updates. Like let's say we go down here. Okay, it just means that this is one state, and this is another state where it plays two animations, and then it goes to another state. But the thing is, we always have to do this kind of sectioned off things here. It's gonna get messy. So I think it's better if this is one entity that has this type of animation. This is one entity that has that type of animation. Then we don't have to worry about that. The question is, how do we create this structure, this overall structure, in data form? I think probably would be great to do. Because then it's like, yeah, we have a sequence, and the sequence is like, first we have this, then we have this, and then we have this, and then after that, this one could, I guess, on its own spawn a bunch of other ones. So each node in the sequence could potentially spawn new things, I guess. So then it's not actually a sequence, actually. It's like, this one has two children, but at the same time, no, actually, first is this one. When that one is done, we spawn two more things, and they should be encompassed in one thing. We have to wait for both of those. When those are done, we create this one, and when that is done, we create three more things. And when these two are done, they create this thing. So that now it becomes a nested structure there. And then this one is separate. I think we could have this in a sequence. It's just that when it comes down here, it's going to be more like a nested structure, yeah. So the nodes in the sequence are either just one animation, or it can be a sequence as well. Well, actually, this is not a sequence. This is parallel. Yeah, so we have like two different kinds of lists. It's going to be either a sequenced list, or it's going to be a parallel list. So animations will run in parallel. And then you also want to wait for them, for both. But here is like, yeah, all of these are running parallel, but we only want to wait for these two to start to play this one. So that is the kind of constructs we would need for this. You know, and for this example, maybe this would be like sheath weapon or something. Or I don't know. Yeah, so just as an example for this specific example, so we can. But this is not probably what we're gonna have, but yeah. All right, we'll see. if I were to make this okay, so the idea is then, and then this would be like something like this, animation sequence. I think man, I'm thinking about a lot of different ideas here, but so animation sequence. So basically, let's say you have like a sequence, and the sequence will have, you know, then it's like a tuple of like things that are gonna run in series, right? So for this example here, this will be the melee attack animation sequence, right? So we'll have like a sequence, and the sequence will have a bunch of so first, what did we have first? We have like move, and then this would be some kind of target, like move attacker, move attacker towards target position, and then the speed is like yeah, some kind of speed, something like that. All right, and once that is done, here's the next thing. We move back, move attacker to original position with the speed. And then when that's done, actually here we need like parallel. So this is going to be parallel. We move the attacker back, and we also spawn a damage number at the target position. And the damage is whatever damage we have. We already have the damage, so it's already calculated, so we know what it is. Okay, and then when these are done, we continue down here. Okay, if we want to match like this kind of thing here, we sheath the thing. So this kind of changes. Maybe it plays a sprite animation of the attacker, and it plays like sheath, like goblin sheath or something like that, you know, or sheath animation. Okay, and then when that is done, if we go according to this tree, we have two nodes spawned like here, and then we have a thing here. So all these are going to be in parallel, but then there's a grouping here as well. So I think what we can do is if we first spawn everything in parallel, but then this item is actually one item in parallel with this item in parallel, but this item in parallel spawns this one. So we'll have, so how that will be is like parallel, and then parallel again. This corresponds to those two nodes that we had. And then this would be something and something else. And then when those two are done, actually this is a sequence here with a parallel. And then, you know what? It's actually not a sequence, because then this whole thing actually becomes like a child of this parallel. So what if, hang on, and then this one is the other one. So let's say that this is A, B, this is C, and this is D. Okay, so this is like A, B, and this is C. And then when all of them are done, we go to D. But that's not correct, because that kind of means that we have to wait for all of them and then go to D. We only want to wait for D's to go to D. So that would mean that, yeah, then D is over here. That's right. Okay, yeah, I think that works. Yeah. So that works. We have a new sequence being spawned out here. And what's good about this also is that it's composable. So you could, because all of these are, I guess, animation sequences, or like some type of animation component, or well, I'm not sure what to call this, like animation step, animation something type. So yeah, so this would be kind of the way you would maybe then produce the tree, or well, I guess it kind of is a tree actually, except it's like it's like trees with different kinds of nodes, I guess. Yeah, because if you look here again, it's a tree. This has, so essentially, instead of seeing this as spawning 2 nodes, we just spawn 1 node, but this node is like a parallel node that has 2 children, right? So it's a parallel node that has 2 children, and then this, and then well, it has 2 children. Well, not well. Actually, no. It's like a parallel node with a different tree, or yeah, with 2 nodes in it, and then this, and then. But then this is then this is just a list in the sequence, in this sequence here. So these could be children, so this is 1 child. The root node, let's say the root node is a sequence. Right. So if we do this in another kind of display here, here's the root node. The sequence is first, I'm gonna call this like MT for move to target. This is MT. Then we have another node, which is a parallel node that has 2. I guess this would be 2 children like this. It's a parallel node with 2 children. Yeah. So it is a tree, actually. If you display it like this. Yeah. And then we have another child here, which is this one, which is like, I'm gonna call this S for sheath. And then these are like move back. And this is damage D. So damage, move back. And then sheath. And then after sheath, we kind of have another child here, which is in parallel again. But all of these are children of the root node here. So we have another parallel with a child that has another that is a parallel with 2 children here. So this is parallel P, parallel P, parallel P. And this is like A and B. A and B. And then we have S, which is, no, wait, S. Yeah, after S comes these things. So we have parallel, and this one is D, like this one here. Or C. No, this is C, right? Okay. And then D will come like... No, I missed a step actually, because this should... Yeah. Oops. This should actually spawn a sequence. Call it SQ. So the root is a sequence. And then this spawns a sequence which first are these two. And then the next item is D. So here is D. So there we go. So it is a tree. It just, I didn't really see it first as a tree, but we can rewrite this as this tree here. I think that I saw it when you look at the code, you can actually, you know, tell it's a tree, because it's like, it's just a list of lists, and that is essentially a tree. So, yeah. I was skeptical at first, but actually, yeah, it is, that works. If you draw it as a tree, you have to add the index of actions. Yeah. How do you mean, like the labels? Yeah, I don't know if it makes sense, like you can see what I try to do here, or what I'm actually doing at all. But essentially, it's like we have two different kinds of like primitive nodes. I guess potentially these could be, these are like, there's like, these are leaves here. These are the leaves. And these are like nodes. But there's two kinds of nodes. There's a sequence node and a parallel node. The sequence nodes, their children will be done in sequence. Parallel nodes, their children will be done in parallel. Right? That's the idea. You could potentially have a lot of different things happening in parallel in this sense. But this is a sequence. So I guess the longer down you go in the tree, maybe there's like more things that can happen in parallel, perhaps. Because this will potentially could span over all of these animations, like these three, for example. Okay, well, I think I'm happy with that actually. Now it's just to build this. Because it's I think it's generic enough to be able to cover like most things that we want to do, and if there's gonna be other things, we can figure it out. So but we won't really have this. This would be like the melee attack essentially. Let's try and you know what, let's try and pseudocode a little bit more here, because I want to also try the ranged attack, and then I'm also gonna try to kind of define, let's say we want to define, I want to define like a fireball, for example, because that's one of, and also like a bouncing, maybe like a bouncing laser or something like that. We'll see. But let's do the ranged attack. So we don't actually move the attacker. What we do is we spawn a projectile, and well, the thing is, like, spawn is kind of the only purpose of spawn in this animation system is only to spawn some kind of sprite to be displayed. So I'm actually just gonna say this is a sprite, and then it's gonna have a source rectangle, and it's gonna have a position. So let's do like attacker position source rectangle. So that is essentially everything we want to do with this sprite for now. We possibly want to set like a rotation as well, because yeah, that could be something that we wanted to do. The trouble we are having here is that we have kind of the way to spawn a sprite. However, we don't really have a way to talk about this sprite further down the line here. So we have a conundrum. Do we want to make this into a monad so that we can actually take a payload out for this sprite, for example, and then use like, and then use that somehow. For example, what we could do very easily is like move. Like, let's say move doesn't take an entity context. Let's say it takes a selector. So we could say like last created sprite, for example. And this really reminds me of the Warcraft 3 editor, if someone recognizes that. But last created sprite. So basically you create a sprite and then you can target it with last created sprite. So that's a very simple construct, but kind of limited as well. But it would suffice in this scenario here. A more powerful way to do this would be to kind of be able to kind of bind this sprite into a continuation function animation that will determine the rest of the animation with the sprite kind of spawn known as a thing. But this would suffice for this simple example here. So we move the last created sprite to the target position with the speed. So we don't move the attacker. And once we have moved it to the target position, we would we don't actually have to do, well, the way it works now is just we show the damage number actually. Yeah, I mean that's it. But as I said, the more powerful way would be to bind this and continue animation. Now the continued animation is going to be, well, we can define a function here. Can you actually define it here? If it's a struct, even though it's like unreachable over here. Yeah, you can. Well, actually it's a function. So basically this would take the payload of the sprite, which would be a, let's just call it a sprite. I mean, I guess this would be an entity context. And then, so now we have the sprite that we're talking about. And now we return the rest of the animation, which would be move. This would be like sequence. Whoops. Actually, we don't really need damage number for this. We just want to move. Yeah. So this would actually just be move. We just want to move the sprite here. Right. So that would be a more like powerful way to do it, because then we could potentially, you know, create multiple things, bind it to different things, and yeah, do like take every one of them, consider every one, and even like fetch. We could even fetch like different data, runtime data on this sprite, to determine what we return as animation. Like the animation return can depend on like different state that we get from the thing. Now we probably won't do that because well, there could be things like randomness, I guess, in the animations themselves, actually. But since the board kind of outcome is already predetermined, or is already known, is already calculated, the animations probably won't change that much. But anyway, this would be kind of the more powerful way to do it, other than the other way. So, or rather than the other way. Now I wish that Zig had better, you know, lambda definitions. You can't really create a, this is the way to create a lambda in Zig. I wish you could just say like sprite move, sprite target position speed instead. But we can't because we're dealing with Zig. So, but yeah. Another way, if we had currying, then we could also do like, you know, move target position speed if sprite was the last the last argument in move, then you could also do that because it would be like partially applied and we get a new function that takes one argument. Anyway, that's too much functional programming maybe in Zig here. All right. Damage delta is important for multiple shots, chains, flares, which may or may not hit in full. Damage delta is important for multiple shots, chains, which may or may not be hit in full. Are you saying that we should, like, yeah, you're saying that sometimes we should like, if let's say we're showing multiple attacks at the same time, like multiple ranged attacks, and it will show the damage kind of be a sum of all the damage that you get from every attack. Actually, I don't remember how we do it right now. I don't think we, I think attacks, are we showing them at the same time? We are. But then you only see one damage. Yeah, that's what I mean. Yeah. Yeah, that's true. That's true. We have multiple kind of animations playing, and then the damage number is, but the damage number should be a sum of all the animations. So what we could do is then, when we decide to play multiple animations at the same time, multiple kind of actions being done at the same time, we could have that be a, like, we could have a parent animation that like orchestrates those animations, and the parent animation will be able to say that, okay, after all this is done, like, let's say, but the problem is though, different projectiles may have different speeds, so it's not going to happen at the same time. I was thinking like, yeah, I don't know. Or maybe like when you show damage numbers, it likes, instead of showing the damage number at the same place, maybe we'll show like a bunch of damage numbers, like 1 1 1 1 1 1 1, or something like that. Because then you would also see all individual numbers. And you would kind of also feel like that the hit of every number. Also, you could kind of see, okay, one hit very much more than others as well. Hello, Dio Monogatari. What's up? Welcome. Hey, your channel popped up my suggestions. Maybe it's because we're both software devs trying to get into game dev. Yeah, maybe. Cool. What kind of software dev do you do? And yeah, nice. Have you made any game projects? Exactly, that's what I mean by nesting sets of charts. You prep them compacted, spawn it as a queue, but it has long electrons distributed. Yeah. I mean, maybe we could do like a special thing for damage numbers. Maybe damage numbers are put into a queue and they would be displayed from this queue. So even though you have a bunch of damage numbers being displayed at the same time, or that are supposed to happen at the same time, they are put into a queue instead, and then that queue gets like its own animation essentially that will yeah, that would kind of be like having animations be able to like mutate another animation. I was mainly a web dev last 4 years, heavy backend, .NET, C# services. All right, cool. I've been in the .NET swamp as well. Well, .NET is not that. It's not that bad actually. I would rather be in .NET than Java, I think. Been in 2 jams, doing a horror game right now, experimenting with shaders. Oh, nice. I've also been in 2 jams, I think. Yeah, gamedev and GMTK 2026. Experiment with shaders. Awesome. Yeah, I've done. You can see I have like the CRT shader here. What kind of shaders? Like, are you doing like 3D or 2D or what are you doing? Also trying to stream the process. Nice. Yeah, we had this exact same idea. Kind of like those fireworks that pop out fireworks like cluster bombs. Yeah. It was very swampy in the early 2010s, but now it's very cool. Yeah, exactly. Yeah, I wouldn't want to go back in time to like the early whatever stuff they had. Like, what was that called? Like the data to access like database. Yeah, they had all like before entity context or sorry entity framework. They had like no before entity framework. They had like these weird data access things that was probably multiple iterations, but it was like yeah, it was very bad. You're doing 3D PSX graphics and the shader is essentially human night vision. Oh, nice. I love PlayStation graphics. Hello, Phil. What's up? What's up? All right. Yeah, I'm not sure about the damage numbers. I think that's actually an interesting issue. It's like when multiple animations kind of it's kind of the issue that I was talking about before when multiple animations kind of conflict. We don't have to solve it right now. We could still make this system, but it would probably be a good exercise to try and figure out, okay, what if we wanted it to be more orchestrated? Well, as I said, one thing that we could do is just to have the animation like always. We always only show. So we always only have one animation sequence in kind of play. So we have the ability to orchestrate everything. But it can be composed of multiple animations. And in that case, the trouble now would be to, okay, well now it's like, okay, how do we actually know if someone put a damage number out? That could be part of the monad, actually. We could have a monad context where damage numbers would be put into a queue, and then we could actually decide in the monad how to deal with those. Not much else going on your side. Yeah, it's going pretty good. I'm talking about like making maybe like an animation monad thing here. Hell yeah, we're monading. Yeah. In Zig, no less. Okay, so what language are you using for game dev, by the way? I hope you say Zig, because otherwise it's not good. So let's say we have like animation monad. And now I'm actually gonna spell out this is a monad. So for example, we have like damage numbers. It could be just a queue, like a list that we append into. Yeah. So, and then the damage numbers are gonna show like whenever a damage number is created, that's gonna basically spawn its own animation. But if multiple are spawned at the same time, we have to kind of we have to wait for the damage to be kind of animated a little bit before we show the next one. So there's like a short cooldown in between the damage number animation. So you spawn a damage number, you wait for a little bit, you show another one. Maybe we can even like offset them a little bit so they have like different like offset positions, so they're not at the same place. So this would be like a list of usize. Actually, I mean, we should probably use an actual dynamic array for this. This would be like usize. Are you using you're using Godot? So C# and Godot shader language. Okay. Yeah, I saw someone actually use C++ with Godot. You can use I guess there was like a bunch of bindings. I haven't tried it. I'm gonna try it at one point. Like Godot. I would have to learn more about Godot, I think, first. But basically you can use like bindings to basically any language almost with Godot, I've learned. Godot shader language also like is a little bit different, I think, than what I'm using here. Never tried Zig. Closest to I've tried is Go. Go is, that's garbage collected, right? Godot is cool in that way. You have bindings for everything. The DX might suck though. I don't know. I think that you can still use the interface somehow. I'm not exactly sure how it works. I know for like Unreal Engine, for example, or maybe even Unity, like the things you do in code kind of reflects in the UI as well. It is garbage collector, right? So Zig is not garbage collector, so it's, yeah, that's a huge difference. I feel like that's like probably the major difference between the languages. Is like, is it garbage collected or not? Well, I guess it's one of the major differences. But yeah, it's a huge one. Because I can go low level memory compared to usual web dev lengths. Yeah. Well, in JavaScript, you can make bit or byte arrays, and you can go WASM. I will put I'll put it at the start of the turn. Calculations the spawn is earliest at the end of the turn that triggered it, seemingly and not contaminate resource by the actual pathfinding. Now, the pathfinding wouldn't happen during an animation. The pathfinding is going to happen at a separate space. Like when the animation is playing, that's the only kind of resource That's the only kind of thing that's going on, essentially. The board state is frozen. Like the gameplay is kind of frozen whenever the animation is played. We don't do any parallel calculations during animations. Even though we could, I guess. But we don't... Again, we probably won't have that demanding calculations in this game anyway. So I don't think we have to think about optimization in that way. And if we come to a point where optimization becomes an issue, then, or performance becomes an issue, then we could just try to optimize it then. So I'm very much in favor of not pre-optimizing or whatever it's called. Okay, but anyway, we have damage numbers. This is going to be empty. Let's have an init function. See if we can actually make this before. Yeah, this is probably going to be the goal for today, making this animation system. Because it will help a lot with making more effects and more enemies and stuff like that. Or monster stuff. The only thing that I'm actually... Well, the one thing that I'm actually thinking about is like what if the player wants to do a ranged action? Now we're kind of getting into the territory of how is the controls going to work. I guess we can always change it later, but I don't know. It feels like there could be a trap there where you define a bunch of actions and then all of a sudden, if you want to map that to, for example, mobile controls, it's all of a sudden going to be basically impossible or something like that. I don't know. Anyway. Enough of that. Let's just do this here, because I think this can't hurt having this system here. Animation monad. The thing is with monad is that we probably want a payload. But this is the context. This is the monad context, so it's not actually the monad itself. Right, this is the context here. Or the state, whatever you want to call it. This is the state here. And then we have the animation actual monad. It's going to be a function. With a type. And it's going to return a type. All right. Now the monad is gonna have the monad is like is one of these. It's like a sequence, a move, a par, whatever. That's what that is. Now the question is, do we want to have this as a union enum? Because it's kind of how we are doing things down there, actually. It could just be a union enum, actually. Once you have animation spawned from an animation, you have independent queue running in parallel standalone, so it can happen that it interferes resource-wise. Yes, that is true. I mean, yeah, you can. I mean, yeah. I think that's just gonna have to be something that we have to like that is like an issue with like a display of animations. I mean that's just an inherent issue that you're gonna have to balance how you create the animations. Really, this is just gonna be a system that helps you define your animations, and then it's like depending on how you define your animations, of course that's gonna be subject to performance issues. If you decide to spawn 1 million entities, then of course you're gonna have, you know, performance issues. So it's like you have. So we have to be careful of that there. So it's like that's just gonna be a case of
yeah, just trying to. I mean, if there's going to be performance issues, there's one other way to fix it. It's going to be like we could, instead of having a list of entities that we iterate through, we could try to use like SIMD. If one, let's say, you want to move a lot of things at the same time, we just use SIMD instead, which is sort of how the physics system does work in the game right now. However, we're not actually using the physics system because we're like moving position. We're moving positions immediately instead of setting up a velocity that then is going to move everything. Although we still have to iterate through everything, yeah. So I don't think there's going to be any difference, actually. It's actually more extra work the other way. Sort of. Okay, well, anyway. Unless we change the physics system to kind of I don't know. We'll see. It's probably never gonna be an issue. It depends on how many entities we're gonna have, how many effects are gonna play at the same time, and stuff like that. So it all depends. So I'm not gonna prematurely optimize anything. I'm strongly in favor of not doing that. So I want to be productive and not get trapped in a bunch of optimizations that we may not even need. I mean, it would be cool to have, but it's like, if it's not necessary, then I would rather skip it. All right. Cool. So we might have a payload for, like, in the monad. So, yeah, that's just a payload. That we just have it there. It might be void as well, which means that this struct will be empty. So I think, well, we'll see. So we have animation monad, which has a payload. Now, the thing is, let's say we want to make a sequence. What else do we need for the monad? We'll see. So let's say we want to make a sequence here. So we have a sequence. Actually, you know what? Let's make it here, or yeah, let's have sequence here. Returns this. All right, and sequence takes a list of animation monads, essentially. Animations. And this would be basically a bunch of this, I think. Yeah. We can also make it void, I guess, because it doesn't make sense in this case to have a type that's going to be returned. The problem is, though, that this, I want it to be a construct method, so I can use .sec. It's a conundrum. What if we make it a declaration that doesn't return this? It's gonna return a void. The trouble now is, let's say we have a function that returns an animation monad of usize or something. Now if we do like return, we can still use .sec. That's good. The thing is with the input though, is it doesn't have to be usize, it can be anything really. So I'm gonna actually call this, I'm gonna do void. It's gonna be a list of animation mode as void, right? And yeah, let's just do an empty there. So is that gonna work? I think that works. Or not. Maybe not. Whoops, whoops, whoops. Well, because it can't define, it can't determine the size, the type here. Yeah, the issue. I mean, I guess we could just have this as this, though. Sure, let's just do it that way. Then we have to kind of determine what to return here. And what if you put in a something that is empty? I guess then we can assert animation's length is more than 0. Okay, yeah, sure, let's do this. And now this has a type here. So if we say void, then this is void, and so on. All right. Okay, so the sequence is going to be. Question is, how do we do this? Do we have maybe like an update function? Also, I think that, yeah, because it's a parallel or sequence. Kind of how we have to think about this is how is the context going to be used? We're going to have like a current node or something like that. Maybe. Wait. Let's go back to the tree and see. The thing is, I think that the thing is we start out here, it's a sequence. So this is kind of the active node. But then we can have like sub nodes that are also kind of active, you know? Yeah, so always, I guess the root node is always kind of active, I guess. It has everything. Once the root node is done, every animation should be done as well. That is kind of the property that I'm seeing here. The root node has to wait. Yeah, that is the property, because there's no difference between the root node and any other node. This node is kind of done when its sub children are done. Then this is done. The same goes for every node. So essentially a node can be done, like is done. I'm not sure if it's going to be a field or something else. But essentially it's going to have like, is it done? Right? And so let's say we update this node. We start here and we check, we have like this list of children, right? So we kind of need to know, we kind of like, do we like instantiate like we instantiate kind of like a state for them. Maybe they can instantiate their own state and you play them until they're done. So maybe an animation has like a, you know, update function where it kind of, you know, it determines what it should do based on its own like update function. So there could be like an update function. It's kind of like, yeah, its own little system here. It has an update function. And the update function would, like, let's say you have a nested, you know, sequence. You know, for example, sequence would just call the update function of the current. Yeah. So the sequence would have to have an index of which child is currently being played. And then let's say we start at the 0th index here, then it calls update on this one. So the update function of sequence looks at what's the current index. It calls the update function on the current index, on one of its children. So the sequence needs like a list of children and the current index. Essentially, that's all it needs. And then a stun is based on, okay, have we played the last animation? Is the last animation done, essentially? Then the sequence is done. And then these animations are like just, they are their own like leaves here. They should also have the update function, and if they're done. And then the parallel, the difference between sequence and parallel then is just that the parallel will call its update function. It will call on everything that is not done. It will call the update function on them. Okay, I think that's good. So every animation essentially will have it's not going to be on the monad. It's going to be like on the, I guess. Wait, how is this going to work? We could, I mean, I guess we could potentially have like a type here. The trouble that I'm having thinking about this is like where in monad land you have like different things, but then in the monad wouldn't actually have the payload on it. Actually, I don't think, no. It would have like, man, why is this so difficult now? Because this is kind of a different pattern that I'm used to. I'm used to like parser combinators, and this is not the same thing. But I guess we would have an update function. So update would be a function that takes the context, which is animation monad context, and it produces a T, I guess. Maybe the context needs to be... No, okay, I don't know. Well, we have the update function, and then perhaps we also have an isDone function. That returns a bool. And then usually you have like a run function that is like, now we want to run this, we want to run the monad with the context. So we'll have the animation monad context given here, we run this monad. So we run self, and this would actually be down here because it's a member function. And then this would return T because that's the payload. All right. And then this would simply run. This would like actually execute the monad. So it's like while is done. While we're not done, we will call update on context. And then in the end, actually update doesn't return T. I guess we do want a payload here, but we don't know if we have it yet. So it's going to be null. Update might give us the payload. You know what? It can be seen kind of like an iterator. Then we don't need is done in that case, because update could give us that information by returning null or the payload. If we get a payload, we're done. It's like a promise. Now I'm thinking like, okay, is there actually room for a stream type thing as well? I guess technically you can have that if you're using an iterator that returns multiple values. But I don't think we really need that here. In that case, we have to kind of refactor this later. I don't think we need a payload then. We actually just call while self update is equal. No, we can't use while. We have to, it has to be, yeah, this doesn't work actually. Because we have to produce something that we can update every frame. We can't just run everything at the same time here. That's right. So we're not really running the monad. Well, we're running it like, I guess, one step at a time. We're running like one frame, I guess. Yeah. So we would call like update. Yeah, okay. So, and this would maybe, I guess this would just give us the thing. It's just gonna be like run, like update context. Oh, I see. There has to be a function here. There we go. Yeah, so we call this like every frame. But then the context has to be persistent though, between frames. So perhaps the sequence would have the context and it would have the monad, which doesn't really, it shouldn't really produce anything. And then in like the update function that I'm gonna make in the, I'm gonna move this to the system later, but I'll just put it here for now. The update function would take update. We don't really, I don't think we need anything else, maybe. Well, we might need game to be able to create entities and stuff like that, yeah. But that probably should exist on the context, actually. So this should probably have game here. And the game gives us access to everything, is essentially. And then when we initialize, the context is going to be init game. Monad is the monad that we need to have. So we're just going to pass that in here. And we'll populate this here. All right, and then the context is defined here, and then we need game as well. All right. And then update will simply call monad run with the context. And I guess if we're done, we get a value, we get the payload out, but the payload is null or it's void, so it's like yeah, we can just ignore it. What if you actually bind that to something? It's just void. So update will, so if we get something, that means we're done. So we should basically destroy ourselves here. So I guess this could potentially just return a bool or an event or something like an update event. If this happens, then, you know, we return true. You know, we have like update event is an enum. We have like none or done. We're either none or we're done. If we're here, we're done. If we're here, it's none. So if we're done, then the system would like destroy this component or this entity, I mean. So next turn, the animation is basically done. It can also emit a animation done event as well, so that the kind of action system would pick that up and all that stuff. So so there we go. Now we're getting somewhere, I think. I mean, there's still the question of how these are gonna work, but yeah, like the main question I have right now is like the context needs to kind of hold like all the, basically like a lot of the kind of state that we need for the actual like animations themselves. So it's like the monad kind of holds the operational kind of things that we need to do, but then the context is what's actually like should hold the state. So it's going to be a combination of those two to be able to do this here. And so, for example, like how would we actually implement sequence? Is I guess the first kind of question here. So basically the sequence, I mean, what we would get is like an update function. So let's just try to do this. So basically this would return init and then sequence update function. I guess we can pass in animations as well. Or it's just, you know, struct sequence update, or just update function update takes a animation monad context. And yeah, this is the kind of the issue here. We have init, and this is the thing. Where do we get this? Like, how do we get our state is the question here. We have to get it from the context. Like, the context is the thing where we should get our state for our node. Maybe the node has a... Maybe we could have a hash map of, and we have like a node ID that we are granted when we start, and then we can use that ID somehow. Maybe. Maybe the context will, maybe actually the update function, maybe we get like node ID here, so we can get the state somehow. I don't know how though. That's the thing. I mean, let's just say we get, because if we can get a node ID here, that will solve the issue, because then we can keep a hash map of like states in here. We can like grab out the state that we need, and now we have like the sequence index and all the children and everything. Well, we have the children. Yeah, we need to actually save the children, the actual children states as well. Maybe the children, maybe they're mapped to their node IDs actually. So we need kind of a way to kind of instantiate a sequence data. So sequence data or sequence state is gonna be like, it has an index, which is the current animation being played, and then we have animations, which is simply a list of node IDs. I'm just gonna call this node ID here. It's just a U size, but it makes it more, you know, so that you can see what's happening here. So we have index animations. So I'm thinking like this together with the animation mode context, where then we could get like the state is going to be context get state node ID. Perhaps we can even you know, transfer it to a specific type, because it might be like an any opaque that we allocate or something like that. Or it's a union enum, and then we grab out the sequence state or something like that, and then this would become a sequence state, and then the implementation would be, okay, well, are we... Wait a minute. If all our nodes have their own animation node, we already kind of have all this infrastructure in place with the ECS system. So the context could include... Now hang on. When we call update, we can definitely provide the context of the entity context. Yes. So if we get entity context here, we pass it into monad run. Okay, and then through that context, so then we would get like the entity context here, because then the sequence end could just be on the entity itself. Yes, so this would be the entity, and then this would just be entity get sequence state. Right. Okay. And then we check, like, are we done? So it's like is done. I guess we could have a function here just for convenience. Are we done? Return if so either, actually we don't know here. So basically either state index if it's more than or equal to state animations length. If it's more than or equal to state, then we're done. So we should return our, like, we should like basically how I usually do sequence, because the problem here is that you get a list of animations and then you have some kind of return type, return value. What would the return value be if you have a list of animations. I mean, I guess it could potentially just be like it could be a tuple, or it could actually just be a list of things. What if type is void, then it's just going to be void. We don't want to return a list of voids. So actually, the return here could potentially just be, it could actually be as animation monad. And then it's like a list of payload of animations. Yeah. So it gives you, we get an animation monad with a payload, and then we return something. We extract the payload from this type. We already have the payload. The payload is just T, right? That's right. So it's just going to be a list of T. So we get an animation monad of T, and we return a list of T. Now the problem with this is I'm not sure if this is going to be able to be used. Like, let's say we want, like, let's say we have an animation that is, or animation monad that is this. We can say .sec here. I'm not sure if it actually works though. This is the issue. So just because the compiler doesn't allow this, I would really wish this would work. But otherwise you would have to kind of use the global sec, and it's going to be like, you know, anim something .sec or something. That could also work, I guess. Yes. So the list of animations is like, well, now actually it's not going to be a constant, not a date. It's going to be the entity context actually. And then, and we still have the index. So it's just a list of entities, essentially, is how you can think about this. We update, we check if our current index is more than animation's length, then we're done. So this function actually should return I mean, I guess it's either a list of T or T. What I was going to say before is that you can say that it returns 1. I'm just gonna do that like this, because otherwise it's gonna be too much of a hassle here. I'm just gonna decide to return the latest or the last item in the sequence. So we need to kind of basically, and we don't need to store it in the state because we know what the payload would be, actually. So the thing is, this shouldn't actually happen. I think we just unreachable here, actually. Yeah. So we should also like assert. Actually, you know what? Let's just assert that state index is less than animation's length. Okay. So you shouldn't call, this function shouldn't be called once we're already done, you know. Essentially is what that means. So we get the state. We're going to get the current animation. It's going to be state animations state index. And we're going to get the next. So it's like if animation. So basically, well, this is the entity. So that's the context. The actual animation is going to be animation context get. And what do we get here? Is it the monad? Actually, we have the monad here. Actually, we kind of have the monad here. we could store it in the state. So this would be the actual entities. Animation contexts. And then we have the animations is going to be a bunch of animation monad T's. So then, okay, so then the animation is going to be animations. Yeah, that's the animations. So there's the monad, and then we have the context. It's going to be contexts. Context. There, that's the entity. So we have the animation and the entity. And then we can say if animation update, or I guess we run, yeah, whatever. Update, run, whatever, doesn't matter. And we provide the context and also animation context, because I'm gonna change this here. I think this should work here. This is the entity. We update with the entity. I'm gonna update this to take entity context. Okay. Yep. So if we get a payload out, we will also check if this was the last animation. If this was the last animation, then the whole animation is done. So this would be like state index is equal to animation's length -1. That means we should already be done. So then we can just return the payload. And that marks that this monad is done, which means that the machinery outside will kind of take care of destroying this monad, so we won't actually call update again. So don't need to do anything else here. We could actually just destroy ourselves as well, but I don't think we need to do that, because then every monad needs to implement that. So it's just gonna return the payload, which means we're actually done. Otherwise, we will just return null. We'll return null, but also we need to update index. I guess we could do it before, so we can do that, I guess. I don't know, it doesn't matter. So we update the index, so next time we run the animation, we know that this animation is done. So now we can go to the next animation, because the index is +1, so we get the next animation. We run that until we receive a payload. If we receive the payload, then we're done. And otherwise, we will return null here. We fall through there. Okay, I think we got it. I think we've got it. Oh, I need to actually get the state here. Okay. I think this is it. Yeah. Yeah. The thing is, like, you have to think about this in a way that it's kind of like how React works in a way. Because React is also like, you call an update function or a render function over and over and over. And you kind of have to check what is the current state everywhere, and then do different things depending on the state. That is, so it's kind of is the same idea there, right? It's kind of like, this is like my state. It's kind of like the state hook. It's we have the state. We grab it. Well, in React, you would like create a state if it doesn't exist, I guess. In this one, I'm actually, the last piece of the puzzle here is probably how to actually construct this now. Where do we like create the entity? Where do we populate? And where do we populate the state? Because we need these entities. I think probably we might actually need two functions for the animation monad. We probably need one that's like initialize. So initialize animation, init animation. I don't know why I started to abbreviate this. Init animation. I usually don't here. Init animation, and well, init is kind of like an abbreviation though, but whatever. Init animation, we would get, do we even need a context now? I think we do need a context. Let's just get the context for convenience. And then we also need the entity context. I think, yes, we do, because we need to create the state and all that. And then this would return void. Okay, so we initialize the animation. That is one thing that we actually need to have as well. So this one, yeah, let's just do this here. So we need animation context, and we need game entity context, and return void. All right. Whoops. And update, same thing, except return t. And then we return init animation equals init animation. Update equals update. Maybe we also need a cleanup. Not sure. We'll see. Maybe we need a cleanup function. But yeah, so sequence is like when, so this is the crucial thing here. When we start a new animation, we actually have to initialize it as well then. So we have the monad, we run it. The problem is here. If we now have a new animation, we have to actually instantiate the animation. The timing of this might be that I have to move it, but I think this is correct. So we get next animation is going to be state animations, state index, next animation context is the same thing, and then we call next animation init animation with the context and the next animation context. Okay, so now that should be initialized, and then next time it's gonna run that, and it's actually initialized as well. Cool. Now the question is, when we run the animation, do we, the thing is, the question is instead, do we not pass in a context, and instead we return a context that we can then call update with? I think that is probably better. Because then we can say that run should only be called whenever we want to start the animation, and then we keep this around to call the update function, because then we have a different, this is like the entry point into the root node. So that would be the entry point, actually. And then we don't call run here, we call update. And we don't call run anywhere here, actually. This is only called on the root node. Call only on root node. Context holds the queue. No, context, well, context, yeah, it holds the queue of damage numbers, but it doesn't hold the queue. So basically, every different type of monad will hold its own, will have its own kind of state that it would keep track of and handle itself. So it's like different kind of implementations of the animation. Basically, yeah, so this is the state that the sequence is using, and then the parallel might use another state, because the parallel doesn't need an index to like be stored between updates. It just updates all the animations at the same time. But it does need to store these things. So the parallel state, I could do that next time. I just want to actually I'll try to create this animation system and use it, and then we'll see if it works, and then I can expand on it. So I want to, so sequence I want to do first, and then we'll do the other one later. So this one will create the context, which is an animation monad context. We'll initialize this with game. We need game as well. And here we actually, do we actually want entity here? I'm not sure. And then we return context. We will say, we don't really run the update. I guess this is more like an init function, to be honest. You know what? Maybe the context has a root monad that is a void. Yeah. Let's do it like this instead. This is the root monad. Because we have one, there's only one root. And then this one has an update function. That has... Yeah, update. We also need, so we have a root monad. We also need a root context. So I guess when we initialize, we would also create. Yeah, this is when we actually create the entity as well. So let's do... I don't usually like to have side effects in the init function. That can be dangerous, but whatever, let's do it anyway. So we'll do... So what we'll do is we will create the entity. This will be the root context, is create entity. Create entity, and we will... I guess we don't really have the monad on the entity itself. We would instead... It's kind of weird, because I guess the monad context could be used in the animation system to play all, like, I guess all animations at the same time or something like that. Yeah. So we get the root context. We would create, so we create that entity. Right. Now this would happen every time we want to start a new animation, like every time we want to start a whole new animation orchestra, this is going to get initialized. I guess we would need a cleanup to delete all these entities as well. There's going to be a whole lot of entities creation and deletion, but I guess that's fine. Because the ECS system has a good, it has a good reusability of the index slots. All right, so great. And then update. We really don't need anything else. We just say root. I think also here we need like root.init animation. Actually, you know what? Init animation could create whatever entities it needs itself and then store that. So we don't actually need a root context. And then when you clean up, it can just clean that up. Because then we don't even need to store the contexts. No, we do need entities when we call update. So when we call update, we need to actually pass in the context. That's the thing. Or maybe we only need to store that. Maybe this returns the context. Yeah, because then it knows what kind of things to put on there. So we could do that. Right. And then we could have like deinitialize takes self. And we call like, then let's say the animation, the monad has a deinitialize, and we pass in the context, I guess, if we want. Then we also need the root context as well, although it could, you know what? Since the monad is connected, yeah. Since the monad is connected to a context anyway, we can also just have a context here. Whenever it is initialized, we populate the context. So it starts out, I guess it starts out as undefined. Whenever we call init animation, we would get, either we get it out or we actually modify ourselves. Okay, we modify ourselves, update, we actually need ourselves here, and then we don't need to pass in that. There we go. Yeah. Yes. Okay. And then we just have to make sure that init animation populates context, and it also has to, yeah, we also have to call init animation, you know. Okay. I think this is good. This is good here. Yeah. Okay. This is why you want to create like a very thin slice first before you settle on this pattern. There's so many changes along the way. Sorry, I'm not reading your messages now, Packrab. I think I'm flowing right now a little bit. It's like a slow flow. Slow but steady. So the update function never takes this. It has a self. Not this. It's gonna be animation monad t. And this is gonna be self context get now instead. Now the thing about this is we pass in, so even though we say animation, which is the monad dot update, we still have to pass in the animation here, which is kind of interesting. So we still have to pass in itself. So it's kind of like a member function, but it's like defined, you know, it's like a V table actually. It's like an implementation, but we have to pass in the thing itself as well. Yeah, actually, this monad, all it is essentially it's a vtable and with a entity. So it's like it's actually like an interface in that sense. You implement the vtable and you initialize with a different vtable. You can pass in any functions you want. And then you have the context, so you know which entity we're talking about. This entity will, I guess we don't really need to check if it's valid or not because the animation system won't do that kind of stuff. I don't think it won't like destroy the things. But yeah, so we got self, we got context. That now all is set up. The init animation, let's see. Yeah, and then we don't need to store the context now either. We just need the monads because the monads themselves have the state to call their own context. So we don't need to fetch context here. We don't need to fetch context here. We will simply call update on animation, which contains the context. Okay. And the next animation will call init animation, but init animation does not require that, but it does require the actual next animation and the context. So there we go. So we call init animation here whenever we need to run it next time. So there we go. I mean, we could also have like, instead of calling it here, which I think is better, you could also have like an if here to check like, is it initialized? Is it not? Is it if it's not initialized, we call init, you know. You can even have like this be like a null and have that as a check whether it's initialized or not. And if it's not initialized, then we call initialize and we use that instead. But yeah, no. Okay, I think that's good. All right, and then let's see, and at the initialized, right. So we need the initialize as well. Now it could turn out that the initialize all look the same. Basically, just destroy the context. Actually, you know what? Let's not make it. Let's just have the initialize here. So it would be like the same for all of the things. Essentially just self context destroy. That is the initialized. Essentially, yeah. You know what? Actually, that's not true. Because this also deinitializes children as well. I just realized, because if we have a tree, we should deinitialize the root, should deinitialize all the children as well. So actually, I take that back. We also need dinit. I'm calling this dinit animation. It's gonna be called from dinit. So we'll call dinit animation. Do we need the context as well? I don't know if we need the context. Let's not care about that for now. We only need our own thing, I guess. So the animation. Let's do that. All right. Whoops. And then I mean, technically it could destroy itself because it knows when it's done. So technically we could just deinitialize here. I don't know. That's I don't think that's important. But okay, so we need a deinitialize function, right? So, and also an initialize function. So this only has an update function. What I'm going to do is I'm going to say this is going to be the implementation of sec. So we'll move the function, update function up here, and the init here will actually want 3 functions. It wants an init animation function, update animation function, or update function, and the init animation function. So I'm gonna say like init animation, update, and the init animations. We need these 3 functions, and we can define them on implementation here. So let's define init animation, and this will take context. I don't think we need this though. The only thing this has is like, oh yeah, also this doesn't need root context anymore. Yeah, and update does not need this. So there we go. And we don't need to create the thing. There we go. We just need to, like, when we run the context, yeah, we'll figure it out. The entry point is not as important, but let's see. And we don't have entity here. Good. Okay. So what is this doing? This one is simply going to, well, first we need to create our context. So self context is equal to, oh, we need game actually. So, okay, but we have game here. Game create. Okay. So there's our context. Then we need to store our state on the context. So we need to add sec state, a new sec state here. And we need like animations is going to be the animation. Now, okay, this is actually a little bit of a conundrum here. Because we need parameters then. Where do we get this from? We can't just take this because there's no closures in Zig. So you can't just take this, put it here. Unfortunately. So I guess another way we could do it is store an anti-opaque pointer. That could be anything, and store the state there. I mean, yeah, that's how interfaces does it anyway. So it's like we can have the state pointer is an anti-opaque. And then the context could even be part of the state, actually. No, it can't. Yes, it can. No, it can't. Yes, it can. Wait, then we don't even need the context. Because we already have the state here. Okay. So then we don't need to create an entity, actually. Yeah. Okay. So what we do is like the implementation, what it's gonna do is essentially it's gonna have the state be, well, we can even have a function here, get state, get sec state, a pointer, and this is animation component T. Whoops. We'd have to implement one for each of these. Unless we just, yeah, and this is just going to be, you know, self.state pointer. And we just do a pointer cast. to do that. And then yeah, I don't think we need to keep track of the IDs. Actually, I'll try this here. The monads themselves will suffice. Let's figure it out. So then, init animation state is going to be get state. All right, we'll get the sex state here. The state will be equal to. Actually, we need to actually, you know what? This doesn't work because we need to actually like create the state here actually. So the state pointer needs to be allocated here. So we need to create a sex state here, right? So we create a sex state there. And then the state pointer is populated with an empty sex state, but the animations is going to be set to wait. Wait, this should just happen here, actually. We create the monad. Yeah. It just happens here. We just create the monad. The monad takes the state. It's an any type. Actually, it's a pointer to anything. And we just set the state to be that. Actually, this could be any type. As long as we pass in, I guess we could pass in the allocator. We can get any state we want. We can create the state pointer by allocator create type of state catch unreachable, and then we populate it with the contents of state. We will pass that in there, so it's a little bit easier. We don't have to do that everywhere. All right, so then we have to pass in the state here. And yeah, potentially. Oh yeah, and then we can just destroy. Actually, we can just destroy the state pointer now as well. Although we do need to know the type, actually, of the state pointer. That's the issue with these things. Well, that could be done in deinit, I guess. Yeah, that could be done in deinit. Yeah. So, because then we know the type, actually. Yes. So we have deinit will take, well, it will destroy the state pointer, but we need to cast it as a, well, we need to, okay, let's do this. Let's get the state. It's gonna be get state, and then we just destroy state as a thing there. There we go. Cool. But then we actually need the context here. So context, pass in the context there. You need to get a context. Don't actually have to specify the names. Just realized. Doesn't matter that much. It matters a little bit. Okay. State pointer equals blah 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 blah. Wait, we don't have context here. Oh man. Oh shoot. Wait, we don't have to. Yes, we do have to. This is the issue. Now, what? Okay, this is bad because the thing is, now we need to pass in an allocator here. And that's not gonna be great. That's not gonna be good. Ooh. I mean, they're technically possible. It's just that it's gonna be super annoying. And it has to be doable in some way. The problem is like this, we need, like the input needs to be stored at some point, somewhere. So this is the issue. So whatever you put into these monads, we have to store it until we like actually execute the animation. So as soon as you need to store something, you need an allocator. So that is the issue here that I don't want to deal with. Because it's technically possible to just accept an allocator and do it, you know, but I don't want to have to do that because then we have to pollute this code with a bunch of allocators everywhere. And I don't want to do that. That's going to be so bad. I mean, one thing that we can do is we can kind of force the sequence parameter to be a comp time type. If it's a comp time, no, it can't be comp time because it's gonna depend on runtime stuff. Man. That's also the thing. How would you implement, for example, how would you implement pure here? So, yeah, node ID is not a thing. How would you implement pure? Because that is like the most basic thing you could implement here. Pure takes anything and basically wraps it into a monad. Okay, that's a super basic. Actually, in this case we have to take T because this is a specific case of monad T. But how do you actually do this? So this is the if we can solve this, we can solve this, because if we have pure, we can just like bind this monad into sequence to be able to use that state when we need to produce the sequence. So we could do that. The trouble is, how do we implement pure? I mean, I think so anyway. The problem is we just need the state here. This is the problem. We need to be able to provide the state that is gonna be like coupled with the monad somehow. That's the issue. So yeah, and there's no such thing as closures. You can like construct closures. It's just that you kind of shoot like it has the same issue though, because you're gonna have an issue. Either you need a specific type to know what the type you want to store is, or you can have like an ani-opaque like we do here, but then you have to know the type as well. But actually, then it has to be a pointer, because otherwise you won't know what state it is. Another way to do it is if this was just state, and this would be a union. I guess a union type, so that we can like pick out the correct union. That could be a way to do it as well, I guess. And then we actually don't even need we don't need the allocator. Actually, that actually could be the way it's done. It's just a little bit annoying. But pure is like, you have a value. The implementation would essentially be the same thing. So we have like all of this crap here. And then we initialize, we return .init with all that crap. All right. And so yeah, because now we need an allocator here. No. I'm just gonna do that for now. That's probably what we have to do. We have to make this into a union enum, which carries the state, like the implementation beneath. What that limits you to is basically, well, it's not going to be a problem in my project, but if you were to do this yourself and you want to kind of, let's say you want to export some kind of interface, if you have the state as a union enum, that can't be extended by other implementations. If it's a pointer to any opaque, you can have any state in here, but if it's just a union enum, it has to be, it's like limited to the stuff that you already have. Unless we restructure this somehow. No, but we still need like a pointer then. Unless... No. Yes. Wait, it can be done if we make it a proper interface, actually. But then we can't use... Yeah, no... Okay, so let's just see if we can make pure here. So pure is like, we actually need a state as well. It's like we need the pure state. The pure state is just gonna have the value, which is just a t. We can even just say it's t, to be honest. So we need the pure state somehow, and it's gonna have the same issue. We're gonna have to cast the pointer to a pure state, and the init animation would essentially, well, we don't need to create this here actually. We can get the state self, and then we can say, actually we don't have, yeah, we can get the state, and then we populate pure state with the value. Actually, it's just going to be value, but this is the same thing here. Like, what do we put here? That's the issue. We don't have access to the value. It's not accessible there. So that's the whole issue here. Unless we have like a maximum, yeah, that's the same thing. Well, okay, another way to do it is, I guess we could have like a maximum amount of limited data here. So let's say we can fit, I don't know, a kilobyte or something. Maybe that's too much. I don't know. Let's say we fit like, or well, there's not going to be that many monads, is there? It might jump up a bit. I don't know. It depends. Like, let's say you have like 20 monads per entity, and we have like 100 entities. That's 20. Yeah, that's 2,000. 2,000. Yeah, that's 2 megabytes. That's not that bad. And then we can store things that are up to a kilobyte. If it goes beyond that, we can't store it here. So that's going to be an error. So we can do it like that. That would actually solve the issue as well and make it also like opaque. I think I'm going to just do union enum. It's like we'll just have like a state, an animation state. Animation monad state is a union enum. And then we're just going to have to define this over here. So it's just gonna have to be like this. So we have like a sequence that's gonna be like sequence state and pure is gonna be pure state and so on. So that's just how it's gonna have to be. So we have like sequence state. We have actually these are dependent on t. So actually this is gonna have to be moved inside, I guess. But yeah, animation monad state is gonna be a union enum, it either pure state or sex state, and this is just gonna be animation monad state. And I guess it's undefined to start with. And this is the state. And we can pass in animation monad state here. So there we go. Now we can store anything there that is defined within limits here. And the problem is like now we have to kind of extend this every time we need to implement a new thing. But that, I mean, it's fine because it's a project that's not supposed to like expose this as an external interface. Well, so anyway, let's continue. I don't know why I have such a gripe with this. We need to move on. Yes, union emails is a tagged union. Yes. Which is like the only type of union that I'm using. I never use a straight up union. I think the only time you would want to use a normal union, like without tag, like an untagged union, is if you need to interface with some kind of C code that uses untagged unions. Well, I guess all C. I don't know if there even is tagged unions in C. I don't think there was tagged unions, at least when like in early C, at least. I don't know if they have it now. Anyway, now yeah, we don't need allocator, we don't need to do anything of that nature. We don't need to have a get state. We don't need to create this here. We don't even, I don't think we need to do anything actually here. And the state is simply gonna be sec state. Well, it's just gonna be, you know, animations is animations. That's it. Okay. And then pure is same thing. This is gonna be pure. It's a little bit annoying that I couldn't get it to work, but yeah, whatever. It would have worked if it was comp time. Then you could have made it work. But yeah, maybe if it was no. The problem is the allocator. You need an allocator. You need to pass the allocator everywhere. It's not worth it. It's not worth it. Okay, so pure is the... Yeah, this is just a value. We don't need to destroy. We actually don't need to do anything here. It's just a no op. Same thing here, I think, because we already set the value. We don't even need to do anything. The value is already set. You know what? Let's just put these together actually as a convention. We don't need to get the state function. All right. Now we actually don't need this either. The state is self.state. So actually, you know what? It actually is not state. It's gonna be self state sec. Actually, yeah, that's true. That's true. Okay. Question is, do we dupe the animations? Maybe we do. Maybe we dupe the animations. The animation list. But technically, you could put like a variable, like a dynamic list of sequences. Nah, I don't think we're gonna do that. The thing you put in is just gonna be... Actually, I think we do need to dupe it because it's stack based. Yeah. Okay. So for this here, we actually need to dupe it. Or... Oh my god, but then if we need to dupe it, then we need an allocator. Oh god damn it. This doesn't work. Unless, but then we have to kind of pre-create the animations. Ah, wait. You know what? You know what? Instead of we could just make it like a animation builder in that case, with an allocator on it. That okay. I think that is probably the way forward. So then the pattern would be like this. You would instead of this, you would do... You get like, you say like, well, we'll have a B animation builder in it game or something like that. Right? Because game has allocator and everything we need on it. So we have like an animation builder. Okay. And then animation builder, you would say b.sec, for example, b.move, b.par, b.whatever. This would make it so that, yeah. And then at the end, I guess we would have to, no, this doesn't work either. God damn it. Because each individual thing needs to be built. No, but here, hello, says Scale. What's up? What's up? Welcome. How's it going? The problem is, like, if we create the animation here and we put this list in here, like it would have to be this, then this list is only, it's like the life cycle of this list is this scope only. So it doesn't work. When this gets put into the state, now this points to an invalid pointer because it's like on the stack of something that's not actually the same thing. We call initialize, but we never really unless we init the animation after we return it, or like we call it fine. We could call like finalize or something. And that would instantiate everything so that we properly dupe these things. It would basically have to go through everything. I mean, it's either that. No, yeah, that's it, actually. No, it's either that or like a global allocator. Is that even possible? Can you have a global allocator? No, let's just do, let's just make GPA. No, heap. Does that work? Actually, wait, we could make it, actually, yeah. We can make an arena with GPA. And then whenever we deinitialize, we free the arena. We reset. And it's like, we can make it public so that, you know, if we're in game, for example, we go to the initialize the entire game, we would, it's not as important, but we can just import whatever this is. This is not gonna live here, but I'm just gonna, oh shit, I did the wrong thing. And then we can just initialize the arena here. We just have a global arena here. Okay, and now we don't, now it's kind of like that has to, now that is a closure, right? This is a closure, right? This has to be, you have to, this is a global, so we can use it anywhere, right? Yes. I'm gonna say answer my own question. Are we cooking? And now we can do the thing that we wanted to do, actually. So I'm gonna go back and type, and state pointer is arena allocator create type of state. Should I wait with that? You're cooked at least. Is it hot? Is it warm there? I think we're like warming up here a little bit. We have been down beneath like 20 degrees for a while, for last week. So pure takes the value, we put in, so now we just have to put value in here. And deinitialize, so now deinitialize would have to actually implement the thing. Because now we have to kind of destroy the state pointer. Actually, we don't, because it's an arena, so we don't even need to do it. We don't even need to destroy it, because the arena will destroy it for us. Unless we have like long-running animations, but we don't. It's just going to be short animations. Everything's going to get destroyed at the end of the animation. Everything gets destroyed. So there we go. Arena. Fuck. Magic. I was going to say something else. I actually sort of did say it, but temperature will drop, rise around 15 degrees a day. Heavy rain, switching with full blast sun. Yeah, it's kind of the same here. I guess you might have more dramatic changes, maybe. It rained a lot like yesterday. I was out running in the rain. Actually, but that was kind of good because it was, you know, I get easily warm right now anyway. Okay, yeah, so we don't even need to deinitialize. Cool. Okay, so then update. Well, update for pure is not going to do anything. Actually, update pure, the only thing you're doing is you actually just return the value that we've stored. So it's going to be like the value is a pointer to t. So we pointer cast this, and then we return the value. So that is like the pure implementation. Pure is often very simple implementation, but this is the pure implementation of the animation monad that we have here. Essentially, you just call it update. It's just going to return its value immediately. Local constant value shadows function parameter from outer scope. That's bullshit, because you can't even refer to that from here. I guess you can if you want to have like type of. Okay, sure. Not in runtime though. And this is not used, so we don't care. Okay. Cool. And then sequence. We could dupe it immediately. Yeah, we have to dupe it immediately. That's the whole problem. Yeah, we have to dupe it immediately here. However, this is gonna be, yeah, it's just gonna be arena dupe. Let's do like duped animations. It's gonna be arena allocator dupe animations. Okay. And then the initialize will grab the state. No, we don't need to grab the state and destroy the state, but we do need to grab the state and free the animations. But we could just have a deinit function here actually. You know what? Since we're using the arena anyway, we don't actually need to free it because we're using the arena. What the hell? Duh. Do we even need a deinit function on these things? Maybe we might not even need these functions actually anymore. Man, arena is magical. Arena is magical. This is awesome, actually. A global arena? Is that a genius stroke of luck? Get out of here, builder. Builder pattern. No. All right. Well, no, actually, yeah, no, because we have a global allocator. What the hell? That solves basically all problems. You don't have to pass an allocator everywhere. Why not just do that? If it works. I hope it works. I mean, why do we have globals anyway? If you can't modify it, or because sometimes Zig would like complain, oh, you're trying to do this in comp time? Fuck you. And then it's like, okay. Well, it's mutable, so it should be like, you know, it should be a mutable global somewhere, right? Even, you know, it's namespaced, but it's still a global. But even if we can't initialize it here, we can still have it as this type, set it to undefined, and then initialize at the start of the program. That is always an option. I don't think we need to do that though, because this is simply this doesn't. I mean, it's just a struct. It just returns a struct. So it's gonna be this then. But this also just returns a struct. So it's like there's nothing really controversial going on here. We're just it's actually just data. It's just data that's being produced here. Is this something that I'm gonna incorporate into every project from now on, like just a global allocator? Why pass in an allocator everywhere? Just use a global allocator. God damn it. Okay. Because I mean, that's how it works in. So essentially, that's kind of how it works in C, where you have like the standard lib, the C, whatever it's called, libc, and you have like malloc and free, and that essentially is a global allocator, right? So it's like, yeah, why not? You know, I mean, I get why you would want to have different allocators depending on the use case. Yes, I am gonna use it if it works. Yes, we just need to have to kind of tie the knot here, as we say here. Actually, we say tie the bag is what we say here. Tie the pouch. Process member space kind of global in a sense. Yeah, I mean these are global, so they will be stored on, like, I don't know. It depends on how Zig's internal compiler works. It could either be stored like maybe they move it to the main function stack or something. I don't know, or they put it in some kind of in the process. The process kind of read write memory area or something like that. But it's mute. I'm saying to Zig, this is a mutable and it's a global. So can I please just use this? Because they allow globals, so you should be able to have a mutable global, you know. Den Sack zu machen. I'm not sure if I pronounced that. So is sack, does that mean, you know, sack or bag? Or we say also, yeah, we have the word sec, which is more like that kind of, it means more like a larger bag. Yeah, it means like a large bag, I would say. Like Santa Claus, for example, is carrying a sack of presents, or Christmas present. Yeah, Christmas. We actually have a different word for Christmas present as well. Julklapp. Okay, I totally zoned out there. Okay, I'm gonna refill my coffee. I'll be back. We'll do one last push here. All right. Alles zusammen. Collect everything. Tillsammans. We say together. Samla. Collect. We also say samla for collect. And semla is a nice pastry. Like your process has only one heap. Yes. But this is not on the heap. This would be on like a read-write only or read-write memory section in the executable kind of thing. Or like when you start an executable, or an executable can define like a memory area that is going to be like read-write or execute code, or and then it like puts a bunch of data there. So that's essentially, you know, how you could, so, and you can have like read-only data, you can have read-write data. I'm not sure if this is put there. It could also like, because of how, you know, depending on how Zig does it, it can also try, like, it could put it wherever it wants, as long as it's like globally accessible. So you know, in a function, when you have parameters, these are just temporary things on the stack, essentially. Well, this is a pointer, so, but it's still, you know, the actual value that sets it to a pointer is a temporary thing on the stack. So that's usually how parameters work. But then, and also like local variables in a function and stuff like that. But then for globals, you could potentially put it into the entry point function's stack area. I don't know if that is more efficient, because usually computers like optimize access to stack because it's so common. So it might be good to maybe put the thing on the stack. I don't know. Or they could be put into like the memory area, which is like a read-write only, or read-write area in the executable kind of thing. Anyway, so it's not going to be put on the heap, because the heap is just, you just ask like the operating system for, hey, give me like a space on the heap to put some memory, and then you put it there, but it's like less efficient. And this is actually not doing that. This is just, or are you talking about like when we actually use the allocator? Because then we do put it on the heap. When we use the allocator, we put stuff on the heap. It depends on the allocator like implementation, because some allocators in Zig can actually put things on the stack. But that you have to be kind of careful, because, you know, you have to kind of know when you can use it and not. But yeah, it's like they have like what is it? Made it abstract, like an allocator interface. It's like abstract. So let's say you have I mean, you have this, let's say here, for example, we have a dynamic array, and this requires an allocator, but you can choose to actually use an allocator that uses the stack instead, if you just want to make something on the stack instead. You can make an allocator that uses the stack. If you just want a dynamic array, like you only use it within the scope that you're in, then you can use it on the stack. But if you want to share, like if you want to like return a dynamic array, you would have to use a heap allocator for that. Otherwise, because the stack gets destroyed when you return from the scope. At the moment, you go for arena reset every turn. Build monads, freely allocated sequence, aka pen task, finish turn, kind of. Yeah, so basically how it works, how I'm thinking about this is that the animation, so basically we have one animation kind of orchestra that's happening. And it's going to be this this kind of thing here with one root animation. I think that's how it's gonna be. I'm gonna collect all the monads, put them in one root, play them in parallel, and then at the end of when all animations are done, essentially. Actually, we could actually return this, because this returns a void optional. So with the same thing here, we would run update, we would look at the return type. So if it's, you know, this is kind of like a bool here, but if this is null, that means we still have animations to run. When this becomes void, then we know that all the animations are done. So then we call deinitialize, which will reset, like clear all the animation data that's being used. Because, yeah, the root will play all animations. When all animations are done, this will be done. And then we can call the init to clear everything. And then the next, you know, then the system will kind of wait for the next kind of turn. And when then turn has been simulated and we need to kind of play animations, then this is all going to repeat. That's how it works, or that's how I want it to kind of work. Yeah. Thank you. I'm glad you I'm glad you think that it makes sense, because it's like there's a lot of things going on here. I feel like the more you program, the more kind of concepts, the larger systems you can kind of keep in your head, if that makes sense. Although sometimes it doesn't help, because it's like sometimes everything is about the details. So, which is impossible to keep every detail in your head, because they change and go away, and you get older. Anyway, we should probably also, like, actually the damage numbers, we're just going to use the arena for that as well. So we can actually just make this managed and put the arena in there, I guess. Yeah, we could just do init with arena allocator. Why not? All right. And then we don't even need to deinitialize, because it's using the arena, so we don't even need to worry about that. All right. Question though, why is the arena outside? I mean, can you not put the animal itself and the bed arena? The problem is that I need to be able to access the allocator from everywhere. That is why the arena is out here. If I were to put it in here, for example, I would need to be able to access the animation mode and context everywhere. I guess technically we could. We could have a global that we initialize at some point and use that. But we need something that is global. I need to be able to access this arena globally to get to the allocator that I want to use. So if I put it somewhere else, I would need access to that instead. If I put it here, I would need access to the animation mode and context globally. Because, again, there are no like closures in zig. So I can't like pass it from anywhere, you know. But as long as it's global, it's accessible from anywhere. So that makes it magical and amazing, actually. All right. Okay, where are we? We don't have any more like things happening here. I think we don't really need init and dinit anymore. I really don't think we need it. Because everything is stored in, like, anything we need to dinit is going to be... You know what, the only thing kind of that we need to do is, let's say we create a sprite. This needs to be initialized. We need to actually destroy the sprite. It could even be part of the animation itself. Like when the animation is done, it destroys the sprite. That's actually true. Like, when do we destroy this animation? When is this animation considered done? I guess it's done immediately. It's just a... Actually, it's just a like a sort of like a pure, except it also creates an entity that then it's the payload. Yeah. And then here we could do like... Actually here, yeah. So I'm just gonna say what I'm talking about here. This would be a sequence, actually. And after this move is done, let's say we want to destroy the sprite. We can destroy the sprite. So there we go. Now we kind of embedded that like logic into here. Great. And if this is a common pattern, then we could also break that out, like make this just into its own thing and just do like sprite and move. And then it's like, yeah, then that's gonna be like its own pattern. So that's also the cool thing about this here. Podcast, animation content, arena, allocator, and make it available. Yeah, but that's what I said. Like if we put arena in here, like this, now it's like it's not globally available anymore. So now this needs to be globally available. We need to be able to actually get this one globally available. So it's like we're just moving the problem over here. And the problem is down here, like when we create a sequence, I just wanted to put in this thing. And it's in this scope that we need the allocator. But we don't have access to anything that is not globally available here. Unless we pass it in as a parameter, but I don't want to do that. I don't want to pass it in as a parameter because that pollutes the user, the use. You know, then down here, the thing is, down here you would have to create a context, blah blah blah. You would have to pass in the context to everything in here. It's gonna have to look like this, which is like, it's fine, I guess, but it's not good. It's worse than what I want it to be, you know? So that's why I want to kind of solve this problem by using a global arena. Right? Do you see the issue here? I would have to pass this context everywhere. And then the context, you would have an allocator on it, you know. So that will solve the problem as well, but I don't want to have to pass in the context everywhere. I just want to do it like this, because this is nicer. I mean, I'm almost tempted just to remove these, because I don't think we ever need these. Because destroy could just do it in its update function. Yeah, I don't think we need this, actually. We can remove these. And then we don't need to even call that. Yeah, that's it. It's actually better. It makes this less complicated. Yeah. Pure is great. We need bind. Can we make bind is the question. We can make map, is probably super easy. Bind. Let's see. Monad. This issue with bind. No, it's not an issue with bind, actually. Let's do... Yeah, this would take this animation monad. It takes a this. So it's a monad of t. We have a map function, or this is like FAMB. It's like it takes, it's a function, it takes A and returns a monad B. This is an AnyType. It has to be an AnyType because we don't know what the resulting type would be. And then to get the resulting type, we would have to say like return type, actually bind payload. No, actually, it's just a return type. Actually, it's just a return type of this. And the return type is a function that takes a function and returns a type, and this will return type of, or type info, type of f function, return type, or else void. That's the return type, because the bind signature is kind of like it takes like monad m, it takes monad t, it takes a function from t to u. I guess we can use that like convention here, and then we get a monad of u. So this would be, this function is like it takes a t and gives us a monad of u. So it gives us a monad of u, and then we just return this monad of u. So that's the signature of bind. So let's see if we can implement this. Returns via the init, the init being pub. So do you mean the init from main? I have no practical experience yet, still not having done extra work today, but you are my only casual learning channel at the moment for that. So treat it more like poking the pig, see what comes out. Right. It's all in the head, my head's first moment to clarify. Right. Yeah. No problem. I was thinking you're talking about like, oh, you see the init. Do you mean that I still have a global arena that we populate with the init, or how do you mean? Because I think that we want the arena to kind of survive each turn, because the arena will allocate a bunch of space and then it will retain that space, but it will like clear its inner. So it essentially will have a chunk allocated. So basically the arena starts out empty, right? Okay. And once we start to play animations, it's gonna increase because we let's say you allocate space for a bunch of animations, right? So then it allocates this space and it fills up some of the space with the data from the animations. And then when the animations are done and we call like reset, it's gonna like still keep its allocated space allocated, so it hasn't released it to the operating system yet, but all the kind of bookkeeping inside will be cleared. So it's gonna be like, yeah, a reset to have nothing allocated, like it's gonna reset its internal kind of index to 0. So when it allocates new things, it's gonna have this allocated from the operating system. We still have this, but we can start from like 0 and move up to the end. And if we need more, it's gonna allocate more. And then in the end, we want release it to the operating system by calling the initialize, and it's just gonna release everything. But it's just a way to kind of retain the capacity between, you know, animation being played, so we don't have to allocate again and again. Yeah, exactly. So we don't have to request from the operating system every time. We retain the capacity. Because apparently sometimes it can take a little time to actually get stuff from the operating system. But if you already have it, then it's kind of fast. Well, it's really fast. Well, it's faster anyway. Anyway, let's see if we can make this happen. I'm gonna copy, I guess, pure. And what's interesting about this monad is it can be implemented in 2 ways. You can implement another. It's like the monad kind of have 2 implementation directions. You can either implement bind, or you can implement another operation which is called join. I just have a much easier time figuring out bind than I have figuring out join. So I'm gonna choose bind, because once you have join or bind, you can essentially define bind or join in terms of the other one. So then you don't need to implement both unless you really care about like optimization. But yeah, it is feasible. The arena actually has that already built in. The arena struct has that functionality built in. So I already have this. The way I've set this code up now, it already works like that right now. So it's actually pretty cool. Okay, so let's see if we can make this work here. So the thing is, we are going to return this monad here. Return type famb is the kind of monad of u, which I'm going to call here. Okay, so what that means, also we kind of need u as well. Yeah, which is like u is gonna be payload here. I guess what you could do is you could expose a payload. This is also what I did in the other one. You can expose payload t. So now if you have the monad type, to extract t is not like super simple in Zig. but you can expose it like this and in comp time. So now we actually do have T available here. So we can say U is payload of MU. All right. So now the implementation would actually return a U here, and self would be animation mode U. Hang on. Yes. No. Yes, it will, because U is the final result. So we're gonna get that. All right. Then in the update function, do we have a state? I guess the state would be the function here. And the monad. Yeah, I guess these two would be the bind state. So bind state needs the monad, which is monad T. Thankfully, we have this information. Oh, this is going to be a function, actually. Okay. This is kind of hairy right now. So we pass in, it's a generic, we pass in that it's probably fine. This is going to be a bind state, fam, and monad is monad, famb is famb. I mean, we can't really have, no, that doesn't work. Oh yeah, this is just type of fam. There we go. Type of fam. Okay. There we go. Yeah, and then the implementation here will say that we have a state bind state famb right? We have the state, and then now we have the monad. So what we want to do in the bind is that we want to run this monad. This is the thing. When you bind something, you want to kind of exhaust the first monad. Well, it depends on the monad implementation. If it's a streaming monad, you would kind of have to, you would want to kind of stream ahead. I guess the value that you get needs to be passed to the next one. But if it's this kind of monad, the monad I have right here, we just want to exhaust the first animation first, and then go on to play the second animation. Then go on to run the second animation. It's going to be interesting because famb will produce a monad of type MU. So we might have to actually store that as well, you know? So actually we need like mu here, which is it's going to be the return type of famb. Actually, it's an optional, and we set it to null. So what I'm thinking here is that if we have a mu, well, I'm putting the cart before the horse is how you say it, right? All right, Penguin. So what we do is first we want to exhaust the first animation. So we are going to get, so basically if the first monad, we call like update on the first monad. We have to pass in the monad and the animation context. Okay. If we get a value t out, then that means that animation is done. Now we need to we need to get mu from famb, which is not available here, so we have to call famb from here with t. So we call famb from t. This gives us the next animation, this next monad animation here. And then we return null because we're not done yet with the whole thing. Because next update, we will call mu. Now, how do we figure that out? Well, before we actually do that, we have to check which state are we in. Like, are we in the state where we have to run the mu now? Yes. Because then this is populated, it's not null anymore. So we get the mu out, and we now run mu update. We don't get LSP because LSP doesn't understand anything here. But mu update, and it's gonna pass in itself. Actually, I do need to be a pointer is the question. The update function, yes, you need to be a pointer. So we need to do like pointer mu there to get that. That's fine. So this is a monad, animation monad u. To get better, I guess to get better like type information, you could do something like this. So now I kind of know that this is an animation monad. So now this update is actually, you get LSP here. But if mu is done, we get a value out here, which is u, and then we return u, because now we're done. Otherwise, I guess we fall through to no, because otherwise we'll run this. We don't want to call update here. That's crucial because then we'll crash essentially. So if we actually don't have, if this is not done, we get down here and we return null. There we go. All right. All right. Great. Cool. Awesome. Yeah. That is bind. Now we have bind. I mean, if it works. And we can also have parallel. I'm just gonna actually, maybe we should implement parallel to see what it will. I'm pretty confident that parallel is just a simpler version of sec. Actually, so this would be parallel state. We don't have an index. We just have a bunch of animations that's played in parallel. The problem is maybe what is the payload? I guess the payload would be the same. It's just the last thing in the sequence or list. Yeah. Let's do that. Animation length more than 0. We update. We will grab a parse state instead. And we will check. We don't have an index, so we don't need to check that. We don't have an index, so we don't need to... Well, actually, what we do is we just loop. We loop through each animation. Actually, with the payload could be the last animation that is completed. Because otherwise we have to kind of store the result. Yeah, that's just going to be... Because I don't think we're ever going to use the return type of these things. So we're going through animations. We update the animation. If we have a payload, we will... And actually what we could store... No, actually we do need to store. We actually have to store... which animations are done. Like how many animations are done. Starting at 0. Every time an animation is done, we will increase this by 1. And then here we'll check if animations done is equal to animation's length. This will be state.animations because we have to store it there. If it's equal to animation's length, then we're done with the whole thing. We return the thing. Yeah, and then we don't even need to go through the rest because we know that those are already done. Oh, you know what? Actually, we need to store like a map of which are done because we don't want to call update on the ones that are done. We could do that. We could also just remove it from the list, perhaps. This could be a dynamic array. Yeah. Let's just make it easy for ourselves. It's a dynamic array. We initialize it with the arena. We don't even need to deinitialize. We don't need to do, but we do need to kind of do. This would be parse state animations equals dupe. Actually, from... Wait. Is there no like dupe here? There's clone, but that only works... Wait, what? Yeah, it has to have a itself. There is no dupe. Oh, and this is unmanaged as well. It's unmanaged, right? Whatever. Okay, but then we don't need to. Yes, we do. We do. We dupe it. We use it. Yeah. We dupe it and we use it. Okay. Animations items now. If an animation is done, we don't actually need this then. We could actually here we need to make an array list that is a bunch of indexes. of things we need to destroy. Animations to remove. It's gonna be empty. Defer. Actually, we don't care about that. So if this happens, then we have to append this into this list. We have to append like the index. We append the index. Okay. And then I guess we'll go through the rest, because we actually know that we need to do that. And then here we destroy. We go through animations to remove items. We get an index. Now what we can do is we can do animation, well, state animations, and then swap remove index. The trouble is, if this is like, it depends on the order, right? This is going to be an ascending order. So if you remove something, you kind of change the index of everything else. So what we need to do is we need to reverse the animations, which you can do with standard mem reverse, which does an in-place order reversal of a slice. And this is a usize slice, animations to remove. Items. Right, so we do a reverse. That's it. It just modifies the items inside. And then now we're going through from the end. So if we remove something from the end, it doesn't affect the items from before. So we can do fast removes there. Okay. And the reason why I don't want to remove things in here is because we're iterating through. I mean, we could do that as well, I guess. We could like modify, we could, instead of iterating through all the animations, we can have like an index that we kind of manipulate. I usually do this pattern here because I'm usually using like iterator, so this was my go-to solution for this. Anyway, we're going through all the animations that are left. So now this stands for all animations that are left. So we're going through all the animations that are left. We update them. If the thing is done, we get a payload. And we remove this thing. I guess the payload needs to be stored as well. Last payload. Or, yeah, sure, whatever. Payload is optional. T is null. Oops. Okay, and then if this is payload. Oh, hey, Lucas Develops. What's up? Rated with 5 viewers. Thank you very much. How did your stream go? How's it going, man? Yo, yo, yo. How's the Vulkan stuff going? Yeah, it went pretty good. Nice, nice. Yeah, I'm doing good. Doing like a monadic animation system in Zig for my game here. We got the UI added. Nice. UI is good. Yes, it's monadic. It it's a functional programming term, essentially. It's from, and I guess you could maybe say it's from Haskell. I can show you here, actually. This is kind of like a taste of what it's supposed to be able to do. You heard about it too. You heard about it today on stream, but I don't know what it is. Right. So basically, it's kind of, okay, so how you can think of it is, it's kind of like a way to program. It's like a different way to program things with like a hidden context, you could say, is one way kind of to look at it, I guess. So basically here is like monadic code where I have a sequence of stuff happening. So first this happens and then this happens. So but the thing is, like, there's a lot of hidden like context stuff. So it's kind of it's kind of allows you to focus on sort of what's important and not like the glue in between, if you understand what I'm saying. So it's a very functional thing. Now there's some other subtle stuff with like monads. Monads, I think what a lot of people struggle with monads is like they're trying to think about it, if it's like an implementation pattern, like if it's some kind of pattern or whatever it is. It's actually more like it's like a pattern of patterns almost, because a monad is not just one struct. It's not just one like construct. It can be anything. Like an array, for example, is technically a monad. Like you can make a monad implementation on an array, for example. And so there's essentially it's just a bunch of functions. You have map, or let's say we start with pure. So in the case of an array, should I make this in what notation should I make? Let's just make like a function here. Well, actually, I can just show you my implementation of pure because I have pure up here. But essentially, you have a couple of functions. Pure is like you take a value, any kind of value, and the result will be like the value kind of wrapped in your monad. And it all depends on what kind of monad it is. So this pure only works, I mean, in Haskell, for example, you have pure, which works for all monads. But this only works for, in my implementation here, it only works for this kind of monad here. But essentially I have this animation monad then. And so this kind of wraps the value into this monad so that other like monadic structures can use it. So then how to use it, essentially, you could say, well, for example here, it's like sprite is producing in kind of, so what you're describing here is like a kind of like a blueprint of what's going to happen later, essentially, when I run this animation. The goal is to kind of, to design, like create a blueprint that the animation system will then be able to play. And so, for example, this denotes that I want to create an entity that has a certain graphic on this position. And when that happens, the kind of machinery will be able to take that entity or create the entity and then kind of return it in the monadic space. And bind will take that payload and pass it into another function, which we then have here. So there we get the actual entity from here. And then we return another monad, which continues the animation. So now we can use this is how you would like peer into the monad to grab out a value. It's kind of like a map. You're mapping from the return type of this into something else here. So it's kind of like explaining a monad simply, I think, is like pretty hard. I think many people have tried to explain what it is. I think to get a feel for it, you actually have to just try to like research it a little bit. Yeah. I think a simple monad is the optional monad, or the maybe monad as it's called in Haskell, where it's like I think what you would do is you would look at a couple of different monads, and then you would kind of see the patterns in between. So for example, you know, you have the map function, right? So let's say you have a map function that takes a monad with payload A. So monad A, and then you take a function that take, I'm just gonna do this, you know, it won't compile or anything like that, but I'm just gonna show here. So you have a function that takes A and returns a B, right? Now we haven't really defined B, but, or A for that matter. But this is how it's gonna, you know, whatever. So let's say you have like, you take, no, example, this is the return type here. So let's say you take a monad A, and then you have a function that takes A, like the payload, and returns a B, like maps it from A to B. And then you get a monad from, or then you get a monad B. So, and then this implementation here is like, it depends on the monad. So the implementation depends on the monad. Every monad has its own implementation. So for example, you know, an array. So let's say this is an array of A, or I know this doesn't really work in Zig because arrays kind of need to be, you know, they need to be allocated and stuff like that. But, you know, this is how it would work in like a functional language. So this is the map implementation in the case of an array. And then you can essentially, you know, just like, let's say you have like a, you know, B array is you know, array of B, you know, something like that. And then, you know, you would loop through array to get the A, and you will say, actually in Zig you can do this. And then you would populate B with f of A, because that's the mapper function. And now you have a B array. So that is kind of the, this is one of the functions, by the way, for like monads, where you can map something to something else. Essentially, another way to kind of think of monad is essentially just you can kind of think it as like a wrapper of a type, like a container of a type. So the array is like a container of A's. And in this case, it's like, it can be either 0 items, or it can be, you know, multiple items, or it can be 1 item. It's different. And then, for example, you would have, let's say you have the maybe monad or the optional monad. Well, here we would have like a, you know, optional A, and the same mapping function, and then you would get an optional B. How would you define this? Well, you would say, if we have an optional A, we get the A, and then we return to get an optional B out. If we don't have an optional A, we just return null, right? So you can see kind of the different implementations here. So that gives you kind of like maybe an idea of what a monad is. It's more like the concept of different operations that you can do on different things, and then it kind of abstracts that, so that you can kind of think of map as a more like abstract operation that works on basically any type that can be a monad. And there's a lot of things that can be a monad, essentially. You can even have like streams of a stream could be a monad, for example. Yeah, but anyway, it's kind of like a, yeah. And then, you know, and then you have pure. Pure is, let's say you have pure is different, because pure takes like just any value, let's say A, and returns the monad A. Here. So a pure of an optional, let's say we have like value A returns an optional A. This just returns the value because it's, you know, in zig it's just, you know, it's just the value because it's kind of like a built-in thing. But let's say you have like an array, well then you would return, you know, this. And of course this doesn't work in zig because it's placed on the stack and it would be invalid by the time you return it. But you know, this is the functional kind of thing here. Anyway, maybe that made sense, maybe not. But yeah, as I said, it's kind of like a list of, it's kind of like a bunch of operations that you think about. So you don't really think about the implementation details kind of anymore. Well, sometimes it's kind of, you kind of get like a higher view is what I would say. So you can define things like this. And you don't really worry about the details underneath. But you do really have to worry about the details underneath if you want to implement your own monad. All right. Yes, do that. Thank you for the raid again. Good night. Thank you. All right. Sorry about ranting, by the way. Attacker position. Yeah, this isn't implemented yet. So let's go back to our current thing. All right. Where are we here? We have the parallel. It was actually more to do here than I thought, actually. So, so we remove the things that we need to remove. We gather up a payload if we get one, and then we return. So here, yes. So here is like if animation's length is 0, so if we don't have any more animations left now, then we return the last payload, and we have to have at least one, like it has to be populated because we are asserting here, yes, we are asserting that the animation length is more than 0. So there has to be at least one animation, and that animation has to return a t. And then we are populating it here when we get one. So when we are down here, we have to have a payload, so we can just unwrap it there. If otherwise, I guess, yeah, otherwise we just continue there. Cool. Oh, you're back, Penguin? All right, nice. All right. So, there we go. Now we so what we need to do now is we need to do like the kind of machinery around this. Also, we need to implement some basic primitives like move, for example. I need to implement move, and yeah, that and damage number we're gonna get to. But I think we're gonna start with move, I guess. And so basically I want to start with this one, and we're gonna skip damage number. We can do this just to test. We don't need finalize. Okay, so that would be, and this gives us actually an animation monad of void. So there we go, because you are void, or should be void, and then you are void. I wish this would be, this would work here. It does work. Oh, because move is not a actual function yet. So let's make move. All right, move gives us a this, and move takes what? It takes attacker, or it takes, I guess, the mover, the movie. It takes the movie, which is an entity, and then it takes the position, which is like the target. Let's do target position, vector 2, and then it takes a speed, which I guess could be a float. All right, and then it turns this here. Cool. Then we need a move state as well. we're gonna have move v is entity, target position, vector 2. It's basically the same thing. We need to store all this data, and then we will return init. The state is move state, mapping all this stuff, target position. We could also, I guess we could just pass in a move state. I might refactor that later, but let's do this here first. So we need that. Also, we need like an implementation struct, and we need to have update function. I think that's all we need. State and update, yes. Okay, so we need the implementation update, update implementation. You take, I forgot already. You take the animation monad and then the context, right? So self is animation monad t, and then the context, and then you return an optional of I mean, I guess, yeah, it's a T, right? Yeah, there we go. We found it. Okay, so we need to get the state. The state is going to be a move state. Right, and now we need to perform the move. So we also need like instance information about how far we've moved, or how many, I guess, how many steps we need to move. We could store here. And once we reach like the target position, we should be done. So we could store like things like number of steps, for example, a U size, and it could be something. And then we have move step, which is a vector 2. So that is how far we'll move. So basically what I'm thinking here is like we'll get the body of the movie. We will apply to component position x, y. We will add move step. All right, and then we'll check like if, and then and then also steps plus equals to 1. Or should we count down actually? So let's say if we're 1 step, we count down to 0, then we are done. So if steps is 0, we return T. The problem is we don't have a T. That's the problem. So yeah, we don't have T. This is the issue here with this thing, because it should always kind of be void. We could try this. We could try and just make it be a void, and we'll see if zig works here. So it's an optional void. This is a thing there, and then we simply return, I guess. That should not return null, I think. I don't know if this even works here. How much do we know about multiplayer stuff? Not a whole lot. Blue. And then right, so but otherwise we'll return null. Okay. So as long as we still have to move towards the target and the steps, we don't even need to store the target position actually. We don't need to do that. We don't even need the speed. We need the movie, the steps, and the move step. That's all we need. Actually, we kind of need the position because in the end, like when we're done, what I want to do is I actually just want to set the position to be the target position, because we want it to actually be the target position when we're done, right? We don't want it to kind of like have precision problems. All right. You're unused. That's fine. Cool. So this actually works. Okay, that is awesome. Oh, it works because this is void. What if this was like U size? It doesn't work now. That's so bad, man. Is it only the LSP that doesn't work? Okay, well, anyway, let's see if we can make this work here. So, melee attacker anim sequence. This is interesting, actually, because who is the attacker here? Do we have to create this? Because you can potentially, I can potentially create this blueprint, have it be like a constant, essentially, and reuse it instead of having to, because that will, it will make it so that, no. We have to we have to allocate it every time. No, that's bad. Let's just do it like this. Yeah. So we have to pass in like the attacker. We have to basically pass in everything that we need here. So, yeah, I guess we'll start there. We can always change this later. So we have target position is a vector 2. We have speed. Original position we can actually grab through the attacker. So original position is equal to attacker get body position. Okay. Game is not used, so let's not have it. Okay, so that is the melee attack anim sequence. We move to the target, we move back. Okay, now we need like this animation system as well. The font, okay, I'll be the bot here, is called, actually I have to actually check this. I have to also always have to check the name here, because there's like 2 different names on the web. There you go. Because they misspelled the name in one of the things. All right. Anyway, yeah, no problem. How would we test this now? We need a system to kind of run this as well. We need the engine to run this. So let's create a system, animation sequence. Now, how would we want to do this? Maybe we have a context around, or we create, now, yeah, we have to actually have the animation context here, because we need to keep it around. Okay, I'm not sure like about the organization of this, but let's do this anyway. So there we go. Animation mode and context. I guess we could keep it around. The damage numbers. If we're gonna keep it around, we probably want to like reset. How is this? Like empty, clear. Clear retaining capacity, I guess. Actually, that's kind of bad. If it's done with the arena, we don't actually... Yeah. We just reassign it. Actually. And the root has to be... Every time we have to like use this again, we have to kind of... we could just init. I guess we could just init. Yeah. All right. Game and root, but there's no root to start with, I guess. Let's just set it to undefined. All right, and then it's like init animation would take self this, and then we would need like the animation is gonna be I mean that's gonna be the animation monad. That is not public. Animation monad void. All right, init animation. This is just gonna set context to init. Yeah, we can just because it's like an arena game, and I don't think we even need game anymore, probably. And the root is animation. So there we go. That's it. All right. We need self. Okay, so update. So how do we know that we should play an animation? I mean, I guess this could be optional as well. I guess it could be optional. We start out with null. So I guess it's like if we have the context, then we have it, or else we don't care. We don't do anything. All right, so now we have the context, and now we can just call update. And if this returns a value, then we're done. We get the payload, which is void. So now we should set you to null, and that's it. And now it's like, well, it's not actually it, because there's a crucial thing missing here. It's like, how do we actually populate, well, when do we actually like gather the animations to play? So what I'm thinking there is essentially how it works now is that oh, you're done. Deferred. Want me? Okay, so sorry about that. So right now it kind of works like this. You have, so every time an enemy does like a turn, or well, the most simple case is when the player moves, I guess. Oh, we have like stuff happening again. I mean, do we even need this? What do we actually need you for? We don't need game. Let's just get rid of you. What's happening? Animation signals. Oh no, what's happening here? Arena. No, wait. Oh, you don't have a thing called. Okay. So you're an empty. Right. Okay. You're empty. Fine. I'm just trying to get this to run here so we can see. So basically how it works now is like it's a turn-based system. So now time is frozen. It's the player's turn because I'm the only entity available right now. So it's waiting for me to make a move. So I make a move. Now you saw me move there, but before I moved, it recorded. So what happening when I press the button? It's gonna create an action. That's the first thing that happens before anything else happens. It's creating an action, which is called the move action, and it has like a direction and a speed and all that stuff. It also and that action has everything that is like contained to be able to run the animation as well. But also crucially, it does update like the actual board state of the game, because I see this game as kind of like a board game with animations essentially. So it's like when you make a move, the board state updates immediately, but the animation is kind of replaying what you did. So when I press, I already kind of have moved over, but the animation is kind of showing that I'm moving as well. So that's how the system works now. So when we create an action, it also makes it so that, so how it works is that we have an action system, or well, the action system is kind of different systems actually. We have the move system. So the move system grabs anything that has a move action on it, and it just does the move. And when the move is done, we emit an event, and then we have an event listener for action done on the turn system, which is essentially governing whose turn it is, because the turn system needs to wait for animations to play out and all that stuff. So the turn system waits until an action is done. So when all actions are done and there's no one left to kind of choose an action here, we will do the next turn essentially. So, and then the next entities is going to be their turn and so forth. So what we need in order for this machinery to keep on working is we need to be able to say, okay, now the action is done. Now the animation is basically played out, so you can go ahead and see if there's anything else to wait for. If there is something to wait for, then we return. If there is nothing to wait for, then we advance to the next turn here. So yeah. So what do we need to do in order to adapt this system to work with the things? Well, this move system, it's kind of like, which I've changed it now to the other thing. So we don't really need the move system anymore, essentially. We can just remove this and replace it with the animation, generic animation system, because basically the only purpose of the system here is just to play the animation, and when the animation is done, we emit an event to say it's done, right? So that's all we need to do, really. And so so that has to be implemented somehow right now with the new system here. So we have like the animation system. So somehow, the thing is here, like somehow we need to kind of, I guess, like when, okay, and how does the action start? The action starts when the player makes a move. So the player makes a move through the input system or through the controllable system here. And the thing is, first we have to wait for our turn. Okay. When it's our turn, we can make a move. Now, making a move is essentially, we're looking at the input and stuff. And if we made a move, then we will... What the hell is this? Oh yeah, we change like the sprite, but it doesn't matter because it's always the same sprite right now. And we get the position and we say, okay, are you blocked? Okay, well, never mind that. Well, if we're blocked and it's an enemy, we attack. So that's one thing. So either we attack something or we move. So basically, we make a move action that will create the move component, and it will also, yeah, change the board state at this stage, and it will add the move component, and then the move system will play the animation. And now we have, so the thing is, like, now we have an entity that has an action component on it. So then the turn system will kind of say like, okay, do we have things that have actions on it? Then we're still playing out animations. So I need to replace this kind of with, well, if we only have one big animation playing, we don't really need to check every entity anymore. We can just say, or if there's anything left here, we can just say, I think we still need to do this one though, because the player can still, I think it can still be the player's turn while other animations has played out, maybe. Actually, no, because the player always does the thing first. I'm not sure, actually. We can keep this in just for safety, but we can replace this now with waiting for the, I guess, like all animations done event or something like that. We can have another event where instead of action being done, we have like all animations are done or something like that. So then this would publish basically here. We would publish. We need like game, and that's actually, that's a global event. That is a global event actually. Yeah. And we don't really have global events. So I have to extend my event system. Well, I guess an easy way to do it is we could just create a global entity that has like the global events. That would kind of extend the system without having to extend it, sort of. Although then we need to create this entity and keep it around, I guess. We have the event system here. This only works for entity events. So I guess we would need to have this for non-entity events as well. I mean, maybe we could say that We have global listeners. We could make global listeners, actually. Global listeners. Yeah, we could. I mean, I guess it could be like a different type of event as well. So this is a global event listener. Yeah. Why not? Oops. So this does not take a entity context. It just takes the event, which is a global event. Yeah. And this would be actually a different tag as well, global event tag. So animation's done. And then the event. This is, I mean, we'll wait with this one. I'm not sure what's happening here. Oh yeah, because this is a component where we want to keep the events. That's right, because we can handle the events like at the end of the, like as in a specific frame time slot. So this would be for the globals. We can actually store them on the system. Then we can store global events here. Global events would be game event global event here. And do we have allocated now? Wait, we have game. Yeah. We got game, folks. Prep lunch, status quo, like how far away do you think? Yeah, I'm trying, man. It's close now, I think. I'm working on the systems that's gonna run this machinery. So once that's done, I can implement a test to see there. Okay, we got global events, global listeners, blah 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 blah. I guess we would also have to do it for global listeners. Isn't this just a function? It's an auto hash map of array list of, oh yeah. And this is git. All right. Cool. And then global listeners is init allocator. Technically, no, I'm just kidding, actually. But technically, the global events can be like a frame arena based thing. So, but yeah, whatever. Init. All right. So then we could have, I guess, this is on. We need like global versions of these. So global on, I guess. Global off. This would be global tag, global listener. Global listeners, same thing. Yeah, I guess, I mean, yeah, that's it. Global tag, global listener. There we go. Okay. And I guess we do same thing in game. We have on off. We can do global on, global off, global on, global off. This is global tag, global listener. There we go. Okay, so now we have that, and now we need to also call the listeners whenever we have events. So these are the per entity events. And then we have the global events. Right, yeah. Items, event, global listeners. And then we just call it with event. Maybe we could have game here. Or something to actually, so we can, yeah, probably wanna pass in game here so we can actually do something here. What was this about? Events to remove. Oh, it's like clearing out the events, right? That's right. I guess, yeah, the same thing would be here. So after this is done, we simply clear out the global events. We like clear retaining capacity. Yeah. Okay. Because it should only happen like once, like we call all listeners, the events, now they're consumed. Yeah. Don't forget to take a break. Yeah, I'm gonna go here soon. I won't be on here for much longer here. I really want to test this implementation here. So I'm probably gonna get it to a point where I can test it. And if we can, like, if it works, it's awesome. But if we got some problems, I'll see how long I can stay to fix it. But yeah, I need to go here soon. By the way, can we embed basics for SX directly in, like in JS, for example, icon sets which shall not be provided as asset? I mean, you can embed any file essentially, if you want, into the executable as pure data. Like you can embed, like you can embed a file. Like let's say you want some icon data is embed file, and then you just have a path and like icon.png or something. This gives you a byte array of the path that gives you the thing. And I believe it works with binary files It works with text files. It's like, you know, it knows the encoding, I think. Anyway, maybe not actually. I'm not sure. Well, you just get the byte array of the data. Anyway. So you can do that, yes. But it's not a base 64 then. You just get the byte array of the actual file. Yeah. Or you can load it in runtime. You know, you can always do that as well. But I guess that would be an easy way to kind of like load a file. But it would be, you know, embedded in the executable, so you wouldn't be able to change it without recompiling. Of course. Okay, let's focus here. So now we have those. Okay, so now the turn system instead can, instead of doing like this thing, I guess I'll keep this around just in case. So instead of doing this, we're gonna do a global on animations done on animations done. When animations are done, we advance the turn. Okay, we don't need to remove a thing. We don't get the context. Actually, what we do get is the game. We don't really do anything with action, so I don't think we need that. We do want to do this though, because we really want to see. There could be like still something that needs to be determined. For example, yeah, the player essentially. Yeah, I'm still not sure if this is needed, but I will keep it in. And essentially, that's it. Like, yeah, animations are done. We can go ahead and go to the next turn. That's it. Okay, and now we also like, no, we don't even need to do anything here because the event system already is updated. Yeah. Okay, I think now the only thing left for the system to kind of be complete is to, now we need to gather all the animations to be played. So what I'm gonna do is for move, first off, I'm gonna go to move system, and we're just gonna disable that, disable the move system, and when we kind of create the move component, because that is called here. I think what we'll do, we create it and we remove it, I guess. It's kind of convoluted. I might change how this pattern is, but I will actually just remove it directly, because otherwise it will just keep. Actually, you know what? I have to remove the entire action, because otherwise it will just keep being there. Yeah, this calls on create, and then afterwards we don't really do anything else. We add the action and the payload, and then we call on create, and then we're done. So we don't need it. The only reason why I kept the action around before was because the animation needed to play out. So now that we're moving move action to the new animation system, so I'm just removing this action right after we create it. So there we go. Now, yeah, the board position changes. We still want to do that, but we might change how that works. However, the onCreate it's created, and the thing that we want to do is we want to tell the animation system that, hey, I want this animation to be played, essentially. So we could take game get singleton animation sequence animation system. I'm gonna call this. It's actually, there's another system called animation system, but whatever. I want then to like play animation. I guess we can have a function called play animation. The animation is a animation monad void, and I think then this could be we need a list of animations to be played. So let's bring in array list, animation monad void. All right. And then when we play the animation, we simply add this to the list of animations to be played. And we need, I guess we actually need like, let's just pass in game here so we can use the allocator. Okay, and then the animation here, and then we catch and respawn. Okay, so we play, so basically play animation, just appending it in. When we update, if we don't, so, okay. And then it kind of like we need, well, the thing is, the turn system, how do, so this is the crucial, this is the issue here. It's like, when do we know that when do we know that animations should be played? That is the issue now. I guess the turn system is like inactive. When the turn system is waiting, and when we don't have anything. Okay, so if this is null, we get the turn system. If the turn system is like, if it's waiting, so if it's advancing, I guess we don't do anything. Otherwise, we go here. If the turn system is waiting for something to start, right? The animation system to start. We could also send, maybe like we could send an event from the turn system to say, hey, now you should gather all the animations or something like that. The problem is maybe something needs a couple of frames to get started, so that's the thing. I think I'm simply gonna check how many are still, do we have active entities? If we have active entities, then we also return, we don't do anything. But now the turn mode is waiting for animations to play, to start to play or being done. We don't have any active entities left to pick their move, and the animations has still not been initialized. Now is the time to do that. So we will create also we can actually store that in here. We can create actually we'll just call like init animation. Right, we need to create our root animation. So create root animation. We probably need like game in here. Init animation root. We will break. Context out. Oops. Okay. So then this would get populated, and then we actually update as well. All right. Now we need create root animation. So what this is going to do is we are going to gather all. So we have all the animations in our list. Probably, maybe, do we actually need game? Maybe we don't need game here, but whatever. This gives us an animation monad void. So the job of this is to take all the animations, put them in a new parallel animation, essentially. So basically just a new parallel animation where the thing that we put in is going to be animations. I guess we can even slice it out. It doesn't matter that much. Are we clearing the animation somewhere? I don't think so. Yeah, we just slice it out. And then we did need game allocator, actually. So we're taking all the animations we have, we play them in parallel, and that's our root animation, right? And then we initialize our context with this new animation. That is the root animation. We will break that out. So now context actually is what we need it to be. We update to start to play these animations. When they're done, we get the thing here. Oh yeah, we also need to admit that the events or the animations are done. So let's go over here. We'll have emit global event. And we have self game. We have event, I guess. Global. I guess. Is it a global? Yeah, it's a global event. Yeah. Okay, and then void. Here we get the event system. And I guess we could just pass it in here. We need this function as well. Emit global event. All right, so it's just going to be appending it into the list. There we go. That's it. All right. Cool. So emit global event animations done. Cool. And then they're done. The animation system has to happen before the event system then to make this kind of work. How's the timing here? Event system happens here. Okay, so it's actually perfect timing because first this happens. Actually, we're not even calling. Wait, we're not even calling animation sequence system here. I'm gonna have to call it as well. So we call update. The event system will pick up, it will say that, okay, animations are done, so let's call the global event listener. That's on turn. So the turn system will get called for the event listener. That will advance the turn, and then the turn system will do the advance thing. Yeah. So that should all check out there. Local constant event, shadows, function, parameters. Oh. Oh, I see. This is the system, right? Whatever. Okay. We have some kind of error. I know where I actually forgot something as well. Components move. Yeah, it's in here actually. Oh yeah. So we play the animation. This could also be a helper on game, but let's just see if we can get this working here first. And now we actually need the animation itself. So okay, so the only thing we need to have the animation. So what is the animation? The animation is, technically we can just define the animation here. We don't need to define it in here, but we do already have like the function here, but I can move this over to here, not here, but here. All right, so we need the monad. You know what? Let's just put this on game somewhere. Actually, not sure where. Maybe here. Again, this will change location at some point, but now we can say game.animation monad. Okay, cool. So now we can say melee attack animation sequence. The attacker is context. Target position is we need a new target position. The speed is, I guess we'll just put 1 for now. So target position, do we have target position here? No, we don't. Target position is going to be board position from int times tile size normal plus a half. Okay. So this animation should now. No, wait. This is the melee attack animation. Okay, yeah. Okay, wait. We need the move animation. The move animation. Otherwise, it's gonna like play it back and forth. But it would be a nice test to test it out, I guess. But this is the movie. Did I already do this? No, I didn't, because yeah, the movie was in there. We don't need original position. We don't need to do anything. Actually, we only need the move, to be honest. That's the move animation. Target position, speed. Okay, we still need these things. Okay. Wow. Will this work now? Is the question. It feels like when you're doing this stuff, it's like sometimes you feel like you did like the whole marathon only to find out if it works or not. Okay, no field name speed in composite. Okay, so now we're here. Now we're at this stage. Come on, 214. There's no thing named speed here. Oh shoot! Yes, we need to actually calculate these things. Well, we can't have. No, we don't. We don't need speed then. We need steps is steps and move step is move step. So we need to calculate move step and steps. So number of steps is going to be something. Number of steps is like the relative over speed, I would say. And what is the relative? Relative equals source position is, well, we need like position is movie get body position. And that's this position, I think. Yes. Okay. Do we have target position? We do have target position. Okay. So it's going to be the relative over speed. The problem is, well, this is going to be scalar 2. And then this will be rounded, I think. I decided on. This is a U size. We need to do a int from float. So now we have the steps. Now we need the move step. The move step is simply relative. Wait. Yeah, relative over steps. Move steps is relative over steps. However, we need to convert steps to scalar 2. There we go. Oh, move step. Why do I feel like as soon as we start it, we're gonna get like a seg fault, we're gonna get a bunch of shit happening. What's happening here? You mixing U size and stuff. Rel is F32 scalar 2 over that. We're rounding, and if what's happening? Oh wait. Hang on. How the hell? Oh, no. We need a distance. That's right. Distance is length of route. There we go. Distance over speed. There we go. We're going to complain about something else. Oh, no. Oh, no. Man, this was what I was afraid of. What's your issue with this? Unable to resolve comp time value. Okay, well, let's do this then. We'll set you to undefined. We don't actually need the GPA. What we'll do is we'll go to main or game. Let's go to game, I guess. In it, we will import this arena from components, animation sequence, arena. We will populate this now with the GPA we got from here. So there we go. Happy? Are you happy now? Please tell me this works. Okay, now we get some other stuff. Okay, cool. It might actually work. You are complaining about probably alignment, yeah. So I think if we do align cast, is it like align cast here? I don't know. You know what? Let's just make a, I want to make a function here is like get state comp time t type self is, self needs to be first at this, and this gives us a pointer to t. We'll return pointer cast align cast. I think, what if we do this? I don't know, state pointer. There we go. So now it's like, no, state, I guess. So now it's like when we do this, we can get the value. It's like get state t from from self. So there we go. All right, bind get state is bind state fand. Wait, it's just self that gets it. Yeah. There we go. Did I do that here? No. Oh, but self is yeah. And then your T, yes, good. And you are sex state. And you are par state. And you are move state. All right. I think I missed a thing, because here we initialize a move state, here we initialize a par state. But here we're just putting in duped animations. That doesn't work. It needs to be an actual sex state here. There we go. And you put bind state. Okay. We're almost there. What is this? Image sequence system now. Okay, we're past that file, I guess. Create root animation. Expected 2 arguments, found 1. Right, self. Components animation sequence. Okay, we're back here. Arena, alligator, dupe. Oh yeah, you need a type. That's right. The type is, I guess it's this. Okay. Expected star T, found T. Yes. Well, let's star you. Probably same in. Wait. Move par. No, okay. That already. Except. Wait, do we even need a mutable monad anymore? Yes, we do, because we have the state on it. But the state is a pointer though. So actually we don't need it to be, but I can refactor that later. I don't need to worry about the details. Sequence system 38. Update. What do you need? Nothing. Okay, is there an issue now because you wait, expected star T const T. What? Oh, because this is const. Okay, it's a classic kind of if-else thing. If we have a context, I want the pointer to the context and release that. Otherwise, we do this, and I guess that's what you do. Hopefully. Animation sequence, self root, update, self, and animation context. What is your issue? Expected 2 arguments. Oh, right. I mean, technically what you could do to avoid that is to rename this to like update underscore, and then implement a function that actually just passes in it instead. That is usually, I guess, that's one way to kind of fix that. All right, I know why you are complaining, because you need this to be a pointer and it's actually not a pointer. There we go. It's getting close. Oh, now we're in turn. Game event type event listener. Are you not the correct? Oh, it's entity event. It's global event. Oh, yes, it's playing. Okay, I was afraid it's gonna like immediately crash and burn there. Let's see what's gonna happen now. I will press a button. Segfault. Okay, we got segfault and address, blah blah blah. Removing done. Removing move. Where did this happen? What? Oh, I actually get a call stack here. That never happens. Animation state. So it did go in here. It did go in here. We're creating a car. We're creating a parse state. So there's some issues with here. This animation is apparently bad. Maybe. Or maybe it's something else. Maybe something happened in the update function of the animation. That could be the case. So that would be the move one. We get a move state. That's what we pass in here. We try to get the body of the movie. Are we setting? Wait, we're not populating the state pointer. I knew it was something like that. I knew it was something like that. I'm kind of getting better at sniffing these things out, you know? Oh my god! It works! What the hell? That shouldn't happen. It actually works. Okay, well, it works in like the most basic way. It only moves. You know what? Let's test this out, because we haven't built this whole thing just to move one square and just to play an animation that just moves like one square. We have to kind of like this is the whole thing. It doesn't even use sequences or parallel stuff or anything. I mean, technically we are using a parallel because this is the only animation that's happening. But let's do a sequence. And first we move to the target position. I'm gonna also grab the original position as well. So then we'll move back to the original position, and then we'll move to target plus original position and see how that looks. Because it's like it won't reflect the actual board state, but oh man, now we get an error here. Wait, what's the error? Why are you complaining? Animation sequence 128. Right, you are a pointer. You are a pointer. And you're a constant monad. Right, that's the issue. It shouldn't be constant, I guess. Yeah, okay. It shouldn't be constant. Right. We can pass in a constant and then we duplicate it, and then it shouldn't be a constant anymore. I mean, doesn't the same go for parse state? Ah, because that's an array list, right? All right. We duplicate it and we get duped animations, which is not a constant. So there we go. Git commit, it works. Yeah, that is probably what I'm gonna put there. I demand highlighted borders. Okay, let's see if it works. Integer overflow, what the hell? How did you get integer overflow for that? Steps -1. Maybe. Okay, my reasoning here is like, once steps reaches 0, we return a non-null thing, which means that we shouldn't call this again. So this means that this is called in like an invalid state, which is bad. I don't understand why that would happen. We grab the current animation, we run it, we get a payload. If we have a payload, we will move on to the next animation, right? If we are done, we return the whole thing. Otherwise, we return all, denoting that we are not yet done. Next turn, we get the next animation, play update on that. I guess it's like, maybe it depends. I know why. Okay, I know why. Hello, Stitch. What's up? Welcome. Okay, I know why. Okay, it's kind of silly. Because when we pass this in, the move thing actually calculates how many steps we have to take. But if the target position is the same as original position, yeah, if you have no payload, I guess it still works, because Zig knows if you've returned a null or if you've returned void. So that still works, apparently. I was actually uncertain if that works or not. But anyway, if the target position is the same as the current position of the movie, then the number of steps to take is 0, right? If the number of steps to take is 0, we should not really have this animation, actually. So what you could do then, actually, is like return, like if steps is 0, let's actually just return like pure void, or yeah, pure, like that, or dot pure to make it a void, I think, yeah. Because then that would basically be like a no-op, essentially. Now it's not really optimized, but yeah. Oh, it never stops. What the hell? Okay, but it does some kind of weird sequence. Wait, why did it? Oh yeah, I see what's going on. Because the board position is like update the board position. So it goes like down somewhere. I don't know where it goes. Now the body is over here, but the board position is like up there. So first it goes. Now it goes to the board position that we want, and then it goes back to the original position. And I don't know where the hell it went now. So Maybe it works, maybe it doesn't work. You know what? Actually, you know what? The issue here is like we're calculating based on the position at when the animation is defined. We should calculate it based on where the movie is when this animation starts, not when the animation is defined. That is the issue. So maybe... No, that's still the case. Yeah. These are absolute positions. Maybe later we'll have like a relative position that makes it maybe a little bit easier to work with. I don't know. Because then you can just say move in the direction or something. Actually, like move tile direction, and then you passing the directions to make it super simple or something like that. Yeah, I think I know what the issue is. I'm gonna try and solve it here. But yeah, the basic system works, so that is incredible. I haven't tried bind or creating like a project tile and all that, but that will come next time here. I'll just try to fix this issue first, and then we'll call it here. Because I'm starting to get hungry now. Okay. Where are we? What's happening? Why is the screen shaking? Is it my eyes shaking or something? I don't know. Move. Right. So this is the issue. Like we're taking the position now and calculating the steps. That is not what's gonna happen. So so what we're gonna do is we're gonna save the movie, the target position. The steps is not, we're not able to know the steps right away. So what we do is we store the speed, because we need the speed. So we just store all the input parameters, and then these things has to happen later, like when we actually start the animation. So is that an indication that we actually do need an init animation function as well? Well, we do need to store the things still. It's just that we haven't like instantiated these yet. So we need the speed as well. And these ones are like, let's just set these to undefined. I guess we can have like a calculate function or something. So position, relative distance, speed, and self dot steps is steps, self dot moves step is move step. So now we can call this function whenever we start the initial animation. Now the problem is, how do we know that we're just starting out, right? I mean, I guess we could technically we just have a bool here, which is like, have you initialized or not? I'm just gonna, yeah, let's just is initialized. Initialize if state is not initialized, initialize. Boom. Why do you move all the way over there? I'm very confused. Oh, no, I'm not confused, actually. I am actually not confused. It's because we like add both together, what I was thinking when I did that is like, I was thinking like, well, it's going to be like, I was thinking like relative position. So this makes sense. It adds both positions together. So of course we would end up like all the way over. But yeah, the system does work. So if we go back, like we go to target position, then go back, then we go to target position again, then essentially every time I press the button, it's gonna like move 1, 2, 3, and then it's done. So, and then it kind of proves that the animation does work. It's just that this is the move animation right now, and I can't do anything while it's playing. So the whole kind of turn-based system also works. Now, I guess the one thing that we don't actually test here is like if a goblin tries to move as well. I'm confused. Sometimes it moves over the corners of the tiles, sometimes over the center. Oh yeah, that was just because of the position calculation. I added both positions together, so essentially it's like the pixel position of from the top left of the map, and the top left of the map is like way up over there somewhere. So if I add both positions, it's gonna get like both this position, which is like the relative from up there, plus like, let's say this position, which is also all the way up there. So both positions added would end up all the way down there somewhere. And since they are half, since I like, the thing is like the center of the body is the origin. So that's where it gets like, drawn here. So that's why it's like half offset. Because if I add two positions together, they are both like half offset from the tiles. If you add two together, it will get like unaligned from the tiles. So that was what's happening there. But essentially just a bug because I added the two positions together. Like a moron. Anyway. But if you add, let's say we add like original position plus tile size normal times 2. Wait. No. Just plus. That's going to go to the right. And then back to original. And then back to target. I'm just kind of demonstrating that this is working. Essentially, this animation system works. So if I move down, it's gonna move. So my prediction here is that it's gonna move. Well, if we look at the thing here, it's gonna move down first, then back up, then to the right, then back again, and then down again. So if I press one time, oh, it actually moved. Okay, it moved like one tile down to the right, because the tile size normal is like, it's like 12, 12, so it would move like diagonally. But okay, but it still works. Hey, it works. You end up at your correct position. So this could potentially be, the movement animation that we get. It's a kind of a funky move animation, but there you go. Okay, but that's going to be it for this time. Next time I will flesh out this animation system and we'll implement the rest of the stuff. So we'll have like goblins moving around and shooting projectiles. That will be fun. All right. But yeah, that's going to be it for this time. So have a nice day. And thank you very much for watching. And I'll see you next time. Now let's send you off to your next destination. Thank you, thank you. Update. Raid. Oh, thank you, Pack Wrap. Well, I can show you what we're dealing with here. Actually, let's search for zig. No. There's never a zig. RPG. I'm trying to find something low level, maybe. Infinite Coder, wait. Let's go. Alright, see ya.